Recording initiated. Okay. So yesterday we realized that the improvement, there are four types of improvement. One type of improvement which we verified yesterday is making the job easier. If I make the job easier, definitely the productivity will go up. Yes or no? We have experienced it ourselves. And not only that, if the job becomes easier, then quality improvement will also become easier. People can effortlessly produce quality products. So as a result, the cost can come down. Your products will become cheaper to your customers. And one more thing that can happen is you will be, of course, you will be able to produce faster also. So the quality goes up, productivity goes up. So all these four are actually related to each other. If you achieve one, obviously, no, it will help you to boost the result with other factors also. Now let's try to understand the basics behind quality, lean, and Six Sigma. And now you see there is an equation. Mathematically, the equation looks same. X plus y equal to z. It means your y is equal to z minus x. Now we need to understand what is x, what is y, and what is z. X is nothing but the cost of manufacturing a product or cost of offering a service and the profit. Whatever is the profit you want to make, you add the profit. And the right side Z is price. So now you know what is X, what is Y, and what is Z. Most of the time, you will be in the scenario of second equation. You know what is the second equation? Profit is arrived by subtracting the cost from the price of the product. Am I right?
Yes.
You can't just, whatever profit you want, you can't just fix it. It's not in your hand, right? Because the price is decided by the market. The price is decided by the competitor's price.
Competitive.
So in such a case, uh, no, your profit completely depends on your cost of making the product or cost of offering the service. So we need to realize we have control only over the cost and not over the price. In such a scenario, if you really wanted to maximize the profit, the only way you can maximize the profit is reduce the cost of making of your product or cost of offering of your services. Am I right?
Yes. Yes,
All
sir.
right. And when you think about the cost, there are two types of components. Why there is a cost? In order to make any product to the required level of quality, there is raw material required, manpower required, machinery required, and inspection required. There are many things. So the cost associated with adding value to the product is known as cost of good quality. The cost associated with adding value to your product. Step by step, you add the value because different processes, different works happening. So slowly your product will get the final shape. This is called cost of value adding. All right. So that is known as cost of quality. And suppose when you are actually adding value to the product step by step, sometimes some failure will also happen, right? You might do a work and assuming that the product will go through the quality check, product will get accepted by the customer, product will meet the customer requirement, but in reality, sometimes it will fail. That means some failure is happening. You might have noticed all of these things, in your company also. Every time item is produced, a certain percentage of the products is getting rejected internally. These are called failures. Do you think some cost will be associated to the failures also? Definitely, right? So those are known as cost of poor quality. If no failure happens, whatever you do, it straight away adds value to the product, then that is known as cost of good quality. So cost of good quality you cannot avoid. Otherwise, the value addition will be a problem. So cost of good quality you cannot avoid. But what you can actually avoid is cost of poor quality. If I reduce the cost of poor quality, what will happen to the overall cost? Overall cost will come down. Yes or no? As the overall cost come down, what will happen to your profit? Profit will get maximized. So the secret lies with reducing the cost of poor quality. Cost of poor quality exists in all organizations. Agree, all of you? Right? Be it manufacturing, be it service, be it any kind of business. Only thing is, we don't, sometimes recognize the failure. A work that can be completed in 10 minutes, if your organization completes the work by consuming 15 minutes, can you see a failure here? Are you able to notice a failure
Yes.
here? What is the failure? You are
5
consuming
minutes. Extra
the
5 minutes
time
extra.
excessively. As a result, the total units produced are less. Can you see that? So there are several ways you can visualize failures. Thorough understanding of what the several terminology, several tools is important to recognize the failure. However, the cost associated with the failure is simply known as cost of poor quality. So you spend wisely on the cost of good quality. So what will happen? Cost of poor quality can come down. That's the way you can achieve bigger profit, right? Your profit can be thicker by reducing the cost of poor quality. The cost associated with the defects, the cost associated with the waste, can if you work on defect reduction and then waste reduction, the overall cost of poor quality can drastically come down. That is the learning there. And see here, any business customer needs faultless quality and on-time delivery, quick service, and of course, customer expect the quality product at a lowest price possible. So in return, the organization must make a profit, isn't it? Must make a profit. So what do we need to do? So we have to we have to ensure consistent quality in our final product. At the same time, our manufacturing cost and the time has to be as low as possible, which definitely demands a combination of capable process and people. We have witnessed it yesterday. What will happen if your process is good and people also good? Then definitely great results are possible. And over and above the inputs, the consistent quality of the inputs, that also are plays an important role. And inputs most of the time is the raw material. There are other forms of inputs also. So then what will happen? Customers will prefer your products and services over others and your competitors. All right. Now, so what do we need to do? We just have to work on eliminating the defects. We need to work on eliminating the waste and as well as delays, if any. Of course, delay is another form of waste. So how can we eliminate defects? By applying the principles of Six Sigma. You know what is the principle of Six Sigma? You arrest all sources of variation at the input. I'm using a word called variation. Imagine the supplier supplies the raw material in different quality every single day. If that is the scenario, do you think you will produce a consistent quality product on the other side?
No.
If the raw material quality is varying, automatically your product will experience variation in the quality.
Variation.
So the output, the variation in the output quality is what will become a big problem later on. How the variation is triggered at the output? Because variation is triggered at the input. So controlling variation is the key. It is actually the variation, if not controlled or if poorly controlled, will produce defects. This is the principle behind Six Sigma or the science behind Six Sigma. That is why you always have the checking for all the incoming material. You also check the processes at regular interval, because if you fail to control the variation here, then you cannot avoid the variation at the output. And if the variations are beyond certain level, customer himself will find out the variation. And then he will start rejecting your product. So the principle behind Six Sigma is reduce defects by reducing variation. And similarly, the lean principle is eliminating waste. How? by eliminating the non-value adding activities. Eliminating waste by eliminating the non-value adding activities. What are non-value adding activities? The activities that do not add value in the eyes of the customer. Yesterday, we have seen 7 types of waste, isn't it? All of them are non-value adding. Unnecessarily transporting your product from one place to other place. By transporting a product, between warehouse and the, let's say, the shop floor at 100 times, what will happen to your product? Your product simply travels. That's all. Customer cannot see, any value in it. And if you store a finished product in the warehouse for 100 days, do you think a customer will find value in it? No. In fact, your product, will lose its life if you unnecessarily store it in the warehouse. So there are a lot of non-value adding activities that can be visualized and then that can be eliminated. And in return, what will happen? If you eliminate all forms of waste, the efficiency will go high, right? It will improve the efficiency. And similarly, eliminating the possibilities of the defects will improve the effectiveness. This is what we discussed yesterday, isn't it? Effectiveness is the focus of Six Sigma and efficiency is the focus of Lean. At the same time, you should not, misunderstand Lean and Six Sigma. When I say Six Sigma is about improving the effectiveness, you need to understand that we are improving the effectiveness without compromising on the efficiency. All right. Similarly, while improving the efficiency, you need to do that without compromising the current level of effectiveness. Just because you are studying Six Sigma, you should not forget other good principles you have learned so far. So no. Right? So the same is the logic. So effectiveness should not happen at the expense of efficiency. Similarly, efficiency should not be improved at the expense of your effectiveness. Both are important. In fact, they are also interlinked. But then the definition wise, there is a difference. What is the difference? Effectiveness means producing defect-free output. Efficiency means consuming exactly required resources. Nothing more than that. Clear, all of you? As long as these basics are very, very clear, you can handle any situation, right? And you can understand any kind of tool, and then you can you will get to know what for you are using the tool. All right. So now there are certain principles to be understood. If you are really concerned about ensuring quality in your products and services, first of all, you must be customer focused. What is customer focused? You should know who is your customer. Customer means your customer segment, the target audience, isn't it? So, for example, right now, the training program, who are the customer?
Me.
You are the customer, right? Is
Yeah.
it just one individual listening to me or a group of individuals listening to me? A group of individuals, your age group, your domain, your educational background, everything, it's important that I should know all those. Yes or no? Then only, I can say I know my customer. Similarly, to whom you are selling your product, you must have a clear understanding. Your target audience, you should know first. This is called the customer focus. Otherwise, always, suppose if I simply assume that you know all the basics and I said away talk at advanced level, what will happen to the training effectiveness? It will go down, isn't it? And then what will be the level of quality we maintain? Zero. Because simply we haven't understood the customer, right? So customer focus means you should know your customer. The customer segment should be very, very clear. And then the customer's requirement also you should understand. You can't expect your customer to communicate everything. Customer definitely will communicate certain things. They are known as spoken requirement. But over and above, there will be lot of unspoken requirement. Am I right?
Yes.
The unspoken requirements are known as expectations. So over and above the spoken requirement, the expectations have to be understood. The expectations and the needs together, becomes the customer requirement. And now when you say, when you talk about customer requirement, very, very important thing is you should be able to measure your, performance against the customer requirement. Now, for example, in the training program, I wanted to measure our performance with respect to all your requirement. Can you tell me one way I can measure our performance with respect to your requirements? What is the way we can measure? I need a number.
By
Come on,
evaluation.
by
Yesterday we
evaluation. Very good.
performed the test.
Conduct an exam and your score.
Yeah.
If all of you score, close to 100%, then, yes, we are performing well. Maybe your feedback, right? And see, these are actually at the, what to say, at the output side. And over and above, in order to understand my performance, I can drill down
Sir,
further
you
and
are
further.
not audible.
Then yes, I can drill down further and further, and then I
It
can
seems
understand.
to network issue from your side.
Fatima, are you talking to me?
Hello.
Come again. What are you saying? Come again. Okay. So the point was, we need to drill down further and further and then try to understand what exactly needs to be offered to a customer. They are known as the CTQs, critical to quality characteristics. They are measurable in nature. For example, the number of tools we discuss here in the program is an important CTQ, am I right? If there are three training provider, one training provider discuss about 100 tools as part of the training program. And another training provider, he discuss only 75 tools. Another training provider, he discuss only about 50 tools. And now customer can make a proper decision, isn't it? Who is doing well, right?
Yeah.
And then the depth of subject, there are many things here. But then the point is somehow you have to drill down and make the requirements measurable. Then only they are known as CTQs, critical to quality characteristics. Correct? So, customer requirement, both spoken and unspoken requirement, converted into a measurable metric. Now CTQs are available. And then you should also know the existence of the internal customers. Suppose imagine there are two trainers delivering the program. Then both the trainers need sufficient time to deliver their content. Yes or no? Suppose if I don't give proper time for the other trainer, do you think he can deliver his content properly? No. So there exists an internal customer you need to recognize. Unless and until you fulfill the requirement of the internal customer, you can't fulfill the requirement of the end user. Am I right?
Yes.
Yeah.
So every process, if it is linked to the previous process, then the process that is depending on the other process should be considered as the internal customer. Am I right? Say for example, you produce parts, and all the produced parts goes to the assembly department. Now, as far as the production department is concerned, the customer is assembly department, because all that I produce goes to the assembly, isn't it? So I need to understand the requirements of the assembly department. What do they require so that the parts can be assembled easily? So that, the final product can go to the end user without any error. So you must have a thorough understanding of who is end user, who is internal customer, and who is external customer, right? If your intermediate output, or if the intermediate stage of the product, if it is received internally within the organization, the receiver should be called as internal customer. If it is received outside the organization, the receiver should be called as external customer. But finally, the person who pays for the product and finally purchases the product, uses the product, he is the end user. All of you are clear here? End user, internal customer, and external customer. All their requirements are linked to, linked, and finally they decides the end user's experience with your product. So this is known as customer focus. All of you are clear now? So in
End
order to
user is
ensure,
also external customer, right? Sir, sorry to interrupt.
yeah, no problem. Yes, ma'am, go ahead.
End user is also external customer, correct?
Correct, you are right.
Or-
You're right. End
Okay.
user is always an external customer. Yes. End user is also an external customer. But then, sometimes if, let's say, let's say government norms. If you are selling a product, offering a service, there are certain norms, regulatory norms you need to follow. Yes or no?
Yes.
If you don't follow the norms, you know what will happen? That regulatory body immediately will come into picture and ask you to pay some penalty or may halt your production, put some, specific conditions. So the regulatory body how can we, where can we put them? Shall we put them under the internal customer or external customer? Come on, tell me.
External.
External
External
only.
customer.
External
Yes.
customer.
So why do we consider them external? Because they'll be very strict with their requirement. The moment you are going to you are not going to fulfill their requirement, then they can immediately go against you. They can bring the news in the newspaper, in the social media. They can ask you to pay penalty. They can cancel your license. The impact will be intense and then negative. However, if the failure is internal, they can come back and tell you, sir, something is going wrong. Can you do something on it? And then you have a chance to rectify it internally. That's the classification, right? Ultimately, you need to understand all the stakeholders involved in the making of your product, in the offering of your service, and make sure everyone is happy. Create a win-win scenario. Yesterday we spoke about win-win scenario, isn't it?
Yes.
Very good. That's very important. And then a system approach, process and system approach. What is a system? Several elements together is a system. Yes or no? Several elements together is a system. In fact, your processes are part of your system. Yes or no? Processes are part of your system. Your process, your people, and the technology, and the machinery, the environment, the beliefs, what your company is believing in. I mean, what kind of, the culture and the environment that exists. Everything together is known as a system. And when it comes to process, we know in any process, there will be set of inputs getting into the process. And then there will be set of activities which will help you to convert the inputs into output. This is what is a process, right? And by rule of the nature, always there will be some variation. All of you agree with me?
Yeah.
The rule of the nature is always there will be some variation. We think that every single day we get exactly 24 hours. But actually it is not. Am I right? It's not exactly 24. Every day we don't get the exact, same amount of time. That's why, once in 4 years, we call it a leap year. Right? So the nature is so complex that certain amount of variation is inevitable. You can't eliminate. Isn't it? So there will be some variation in the output, which you must accept. All right. So these are certain characteristics, the inherent nature of any process. Any process will have input, set of activities, and then the output, and variation to certain extent will definitely be present at the output because of the inherent nature of the process and the input. You can't say my company produce output with zero variation, not possible. There will be some variation that you must accept. And reducing variation is the key to improvement. As long as the variations are small, invisible to your customer, you don't have to worry. The moment variation is visible to anyone, then you should be able to control it and make sure you only have the minimal variation which you cannot control. That is called as, the noise effect. That's known as only uncontrollable factors should play. All the controllable factors you must control. All of you agree with me on that? All the uncontrolled, see, Right now the training program is happening, and there are certain factors we can control, but there are certain factors we cannot control. We don't know whether you all have finished your dinner or not. I don't know. It's beyond our scope of our control, isn't it? All
Yeah,
that
right.
we expect you to pay attention. We can encourage you to interact. We can motivate all of you to ask questions, and all that we can do. These are all controllable factor. But
Hmm.
your room temperature, are you sitting in a AC room or non-AC room? We don't know. That's beyond our control. So what you need to understand here is all the variation should come only from the uncontrollable factors. All the controllable factors you must take efforts to control. Then quality can be guaranteed. That is the point. And finally, factual approach. Any decision you take, the decision must be based on the facts, not on the opinion. Anything, any information that comes to you can be called as an opinion. But what is actually true, that is known as the fact. So in order to convert the opinion into a fact or validate whether the opinion is a fact or not, you must be data driven. You must be data driven, right? And then all your suppliers should deliver optimal result. There are some people supplying the raw material. There are some people supplying the child components. There are many small components that you buy from other suppliers, isn't it? Their quality becomes the integral quality of your product. So the quality maintained by your suppliers decides the quality of your final product. All of you agree with me? So you have a responsibility, a very important responsibility to ensure all your supplier deliver optimal quality while supplying raw material or whatever they supply. Agree, all of you?
Yes, I agree, sir.
So that's
Yes,
why,
yes.
all the audits you perform should be a fair audit. No compromise, isn't it? If you are a
Yes.
purchase manager purchasing raw material for your company, don't just look for a cheap material. Rather, make the scenario win-win. Let your supplier make money. At the same time, you must get the quality material. At the same time, you should also be profitable. Yes or no? If you had the interest of any one of the party, in the long run, both of you will fail. Yes or no? Our business should survive forever. So creating a win-win scenario is very important. So don't compromise on any of the important, the requirements here. These are quality principles. Hope you could understand. I will also play a video to help you understand what will happen if you don't respect these principles. See, when I say principle, can somebody tell me what is the meaning of the word principle? Principles means already proven points, isn't it? There are hundreds of standing evidence available for each and every line written here. Then only we call it principle. If you live in harmony with the principle, you will attract good results. If you live in harmony with the good results, you live in harmony with the principles, you will attract good results. If you live against the principles, you know what will you attract? You will definitely attract bad results, negative results, no doubt on that, isn't it? Your parents and your what you call your definitely elders would have given you a lot of advices. Am I right?
Yes.
And see, parents normally give good advices only. Is my understanding correct? So you don't have to reinvent anything. Simply just take it granted and then just start practicing it. Parents say no, don't. No, it's not a good, good habit or a good idea to keep, lying while talking to others. Don't lie and don't steal money from others, and always share the love. And these are all some best practices. These are proven principles, isn't it? If you love your family, then your family will love you. That can lead to a good life, isn't it? So these are certain lessons learned by our, elders, and they are sharing with them as principles. Similarly, there are many companies, they succeeded and they brought out all these principles. Nothing wrong in practicing, isn't it? These are like best practices. You don't have to suspect or you don't have to research any of this, you don't have to reinvent the wheel, simply follow. So that's the point. Omar, you have any question to me? Okay. So now, let me play a video, and before we go to the Six Sigma, see all the principles, whether it is Lean or Six Sigma, everything, finally will be aligning with the quality principles. So let me play a video.
Output.
Yeah, know your input and output. This is called process knowledge, right? A process can be divided into no series of steps, right? A sequence of steps in a proper order is what is a process. And every step there will be an input and output. So you need to know what inputs are needed to produce a particular output. Okay, very good. Process thinking. Then,
The decision should be customer centric, internal
yeah,
customer
you
and
should be
out.
customer. Yeah, always you must be customer centric because the entire business is working around the customer. If there are no customers, be it whatever product and whatever facility you have, it will be a meaningless one, isn't it? So make sure you run your business completely around the customer requirement. So customer requirement is the most important thing. Very good. Then that's all. Only 3 for 4.
And quality
There
should
are
come fast before growth. I mean,
very good.
it's
Before growth,
simultaneous, but
plan your quality before planning your growth. Yes or no? Otherwise, you might think that you are growing, but actually you are damaging your name everywhere because you don't have a quality, isn't it? So scaling up should happen after, achieving the desired level of quality. Very good observation. What else?
Integrity.
Integrity. Very good. Yes. That means, we have there has to be, alignment, employee involvement, isn't it? If employees feel, disengaged or isolated, and if they involve themselves fully, then achieving quality will be very difficult in those environments. All right, good. Integrity. Then that's all. You have spent the 6 complete minutes with the video. What other points? Quality is a carefully constructed cultural environment. Quality is a result of carefully constructed cultural environment. Yes, sir.
Yes, sir.
So most of the time, the environment, is the reason for the results. All right. Agree, all of you?
Yes. Internal audits should be done.
Yeah. Yes, we have to. We have to verify things internally also whenever needed. All
Checklist
right.
should be there. Checklist.
Checklist. There has to be a checklist, and so that you always have a proper verification of everything. All right. So I believe you have grabbed all the points. And the consequences also you might have witnessed, isn't it? Many big companies. We talk very big about Toyota here, but Toyota also had a failure. You might have noticed in the video. The product recall. Several million cars were recalled because of the problem with the braking system and floor mat. So see here. I have listed certain principles which are applicable under the Lean and Six Sigma. What is the first one? Focus on the customer. Second one, understand how work is done. Identify root cause of the problem and focus on solving it. Why you should identify root cause and solve the problem? Otherwise, the same problem will occur
it
again
should
and
not,
again.
so that
Yeah.
it should not reoccur again.
Very good. Exactly. You can prevent it from reoccurring. If
Yes.
you have the habit of just acting on the symptoms, it's only a temporary relief, right? Not a permanent relief. So,
Yes.
very good. Remove the waste and non-value adding steps. Reduce the defects by reducing variation. This is Six Sigma. This is coming from Lean. Communicate and collaborate with your team. See, the statistics says that the big one of the big reason for failure of a project is poor communication, within the team members. Agree, all of you? So any communication, should be, should be very, very effective. Whatever the information you really wanted to share, that should be shared effectively. There has to be a proper communication plan, right? The communication frequency, the communication mode, and then, are very, very important while working in
Internal
a team.
trainings. Internal
Yes.
trainings should be there.
Yes, internal trainings and all that plays a very, very important role. Be flexible and use data to drive the change. Don't just go with the words, believe in the data. All right. So the key focus of Six Sigma or Lean Six Sigma. Our survival is dependent upon the growth of the business. But the business growth is largely determined by customer satisfaction. But customer satisfaction is governed by quality, price, and delivery. But quality, price, and delivery depends on the process capability. What is process capability? The effectiveness and the efficiency. The effectiveness depends on variation. The efficiency depends on the wasteful activities, isn't it? So process capability talks, there are two things which should be considered while talking about capability. The effectiveness, the other one is efficiency, right? So the capability is greatly influenced by variation, because variation leads to increase in the defects and hence increase in the cost and the cycle time. So to eliminate the variation, you must apply the right knowledge. All of you agree with me? Because
Yes.
when I say variation, not many people can easily understand, isn't it? How to measure the variation, how to quantify the variation. So you need to somehow quantify the variation. Look at the data and do something with the data so that you understand whether the variation is high or low or moderate. And then work on reducing the variation, because the rule is, the science is, if I reduce the variation, defects will automatically vanish. And there is scientific, knowledge required to eliminate the defects as well as the waste. And that means, in order to eliminate the variation, you must apply the right knowledge. And in order to apply the right knowledge, we must first acquire it. And I really appreciate all of you being in this platform, because you are here to acquire that needed knowledge so that you all can work on reducing the variation. Irrespective of the industry and irrespective of the problem, the secret idea to solve all problems in any industry is, what is the secret idea? Reduce variation. Very simple. All right. Okay. So quality means understanding the customer requirement. Quality means meeting customer requirements consistently. In order to meet the customer requirement, first you must understand the customer requirement. According to our discussion, understanding the customer requirement means understanding the customer segment, understanding their spoken requirement, understanding their unspoken requirement, finally converting all of them into a technical requirement, and then finally converting the technical requirement into a measurable metric, maybe number of measurable metric, and each one should be called as CTQ. All right. Then only the first line is complete. What is first line? Understanding customer requirement. What did I say here? Understand the customer segment, understand their spoken requirement, understand their unspoken requirement, convert all of them into technical requirement, right? And derive measurable metrics, n number of measurable metrics. And each metric is known as CTQ, because it is fundamentally derived from the voice of the customer. Fundamentally derived from the voice of the customer. So unless and until you drill down the requirements of the customer into CTQs, several CTQs, you can't say you understood the customer requirement. Am I right?
Yeah, right, sir.
The second one, once the technical requirements, CTQs are known to you, then you can design, develop a design, and ensure the design meets the purpose. Some sort of design thinking is very important. Then you develop the process. Develop the process. Why process must be developed? Why not we produce the parts without a process? If you produce the parts without a process, then consistency will be a big problem. The quality of your first product and the quality of your nth product should be same, should be close to each other. You can't say, sir, I produced 10,000 parts. So no, so every 100th parts there will be a problem. You can't say that. So you need a process. So develop it. And once such a process is developed, then the remaining job is you just have to control the process. If the results are good, if the outcome of the process, particularly the outputs are good, then just continue controlling it. What is controlling? Controlling the input. You control the input, automatically output will be under control. And whenever you notice a deviation, then you need to stop the process and then improve it. Right? And primarily, most of us will be responsible for this particular job. What is our job? Process control and process improvement. If you are happy with everything, and once you realize further improvement is not required, you can standardize the process. You can standardize the process and step-by-step instruction of executing the process, you can prepare and then share it with your team member, right? So these are the 4 steps towards achieving or making a great quality product or offering a quality service. Clear, all of you?
Yes, sir.
Very good. Now, process improvement approach. Process improvement is the key to improving your business results. Imagine you have an orange tree, and over the years, you have grown an orange tree. Now, what kind of fruits the tree can give you?
Orange or
Orange.
It can only give oranges because we have grown an orange tree. Similarly, if you develop a process, whatever the results expected out of the process will deliver that result only.
yes.
Suppose for some reasons you're not happy with the oranges, you wanted apple. Tell me honestly, will you be able to produce apple from the same orange tree?
No.
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 Definitely impossible. If that is the
Not-
case, whenever you
No,
need
you are like
better
looking
result,
at
how can you expect a better result by running the same process again and again? How many of you believe that you can produce better result by running the same process again and again? Better results requires better processes. All of you agree with me?
Yes.
Yes, sir.
But the biggest problem with many industries, many workplaces is they are so resistant to change. They don't want to change anything, but they only need better result, which is not possible. So here the solution is process improvement. Solution to the problem is process improvement. First of all, you must accept that there is a problem with your process. All of you agree with me? If you are
Yes.
not happy with the result, first requirement is you must agree that yes, there is a problem in my process. Somewhere something is wrong. That's why I'm not getting the desired result. So stop the process, study it completely. Look at each and every step. No, you execute as part of the process and find out where exactly is the problem. What is the problem? Your target is different and your result is different. The gap in the performance, you could see that, isn't it?
Yes.
Let's say your result is on the right side of the equation. What is that equation? Y equal to f of x. So here the statement says, if you want to change the fruits, you must necessarily change the roots. Similarly, in any organization, if you want to change the results, you must necessarily change the process. Process are the roots that gives fruits in any organization. Yes or no? The process gives the result. So mathematically, we express a process in this manner, y equal to f of x, where what is y? The output. What is x? The input or set of inputs. Sometimes we call y as response variable. Sometimes we call y as dependent variable. Particularly in mathematics, you might have studied y is a dependent variable. Why do we call it dependent variable? Because it always depends on the value of the x factors. Very good. Value of the input. The value of the input decides the value of the output. Coming on to the right side, the input factor, sometimes we call them as the predictor variable because they help in predicting the value of the y, right? Sometimes we call them as the causes. The root causes are normally the x, yes or no? Any problem with your y is because of one or more x. Those one or more x troubling your y are the root causes. All of you, do you understand the process? This is called the process thinking. Always you must think in terms of the process. Then you will be able to, fix any problem very effectively. Now, just to apply this thinking, let us consider a product. The product is, a coffee. We all drink coffee, right? So the characteristics expected in the coffee is, taste. Yes or no? Anybody who is drinking a coffee, he definitely expect the taste. When I say taste, it looks very subjective, qualitative, isn't it? So I need numbers. If you are really concerned about how tasty your coffee is, you must somehow convert this particular characteristics into a number, into a measurable number. So first of all, let us identify or drill down the drivers behind the taste. What makes the customer to say the coffee is tastier? Can somebody speak now? Tell me, when will you say your coffee is tastier?
After drinking.
Come on, when will you say the coffee is tastier?
Aroma
Aroma, yes. It should smell perfectly the way you want, isn't it?
should be fresh.
Yes,
and
should be fresh. That means you want a hot coffee, isn't it?
yes,
Sir,
properly brewed.
yeah. See, the first one I agree, the aroma. The second one, it should be hotter, hotness, isn't it? Coffee must be stronger, yes or no? Appropriately stronger, not too
Yes.
strong or not less strong, appropriately stronger.
Yes.
And coffee must be sweeter. If all the four requirements are fulfilled, it has the right aroma, it has the right amount of sweetness, it has the right amount of strongness, it has the right amount of
Temperature.
what do you call the hotness, isn't it?
Yes.
Aroma,
Yes.
strongness, hotness, sweetness. Four drivers. Can you see that? Now, from the driver, you must identify a measurable metric. Suppose if you can't measure, the only way you can understand your performance is taking customer feedback. Yes or no? If you don't have any measuring instrument or don't find any means of measuring using certain instrument, then the only way you can understand your performance is relying on the customer. Sir, you yourself, please tell me, how is my coffee? Are you happy with the sweetness? Are you happy with the hotness? Are you happy with the strongness? Isn't it? But if there is a way by which you can measure yourself, you should go for it. All of you agree with me? There are instruments which can help you to measure the strongness of the coffee. Am I right?
Yes, sir.
How much coffee powder you have dissolved? That can be measured using an instrument. I think there is the metric is known as TDS, total dissolved content in the solution. Isn't it? Similarly, the sugar level can be measured. The hotness can be measured. Now what do you call the strongness can be considered Y1. See, the taste means bigger Y, capital Y. Taste is capital Y. When I drill down, it becomes Y1, Y2, Y3, Y4. What is Y1? Aroma. What is Y2? Strongness. What is Y3? Sweetness. What is Y4? Hotness. When all these Y1, Y2, Y3, Y4 are met, the bigger Y is met. Yes or no?
Yes.
Now, what are the inputs required so that you can meet Y1, Y2, Y3, Y4? Because this Y1, Y2, Y3, Y4 are the CTQs, critical to quality characteristics. What are the inputs needed? What are the X factors using which you can make a coffee? Milk you need? Yes or no? Milk?
Yes.
Coffee powder, sugar.
Coffee
Sugar.
powder, sugar, water.
Fire or stove.
Stove you need, very good. You need a chef, isn't it? You have to give them a set of instruction. Some people add water also. All of them are, X factors. Like they are denoted as X1, X2, X3, X4, X5, X6, and X7, and so on. Clear, all of you? All these X1 finally, help in achieving the desired value of your Y. Y1, Y2, Y3, Y4. Yes or no?
Yes.
Now, let us assume there is a problem with the coffee. Let's say the coffee is not appropriately stronger. A particular variant of a coffee should have a particular level of strongness. Am I right? If you go to Coffee Day, they have 10 varieties of coffee.
Yes.
A particular variant of coffee should have a particular level of strongness, but that's not happening. There is a problem with the machine. Now you need to fix the problem. Tell me, what will you look at now? Since the customer is complaining about the strongness, you need to check whether the right amount of coffee powder is used in making the coffee. Am I right?
Yes.
So the coffee powder is critical to the strongness in the coffee. That is why you are directing your investigation towards coffee powder. Am I correct?
Yes.
Coffee powder is critical to the strongness. Similarly, sugar is critical to the sweetness. The brewing temperature is critical to the hotness. If you don't brew the coffee at the right temperature, customer will not receive the coffee at the right hotness. Am I right? All of you?
Yes. Yes.
Yes, sir.
So, every problem is connected to a certain X factor within your process. A problem with the characteristics of your product is definitely connected to one or more X factors within your process.
Yes.
Those factors which has the ability to influence your particular Y are known as the critical factors. Only the critical factors can influence your Y. Yes or no? So those critical factors are nothing but the root causes. There can be one critical factor or there can be multiple critical factors, depending on the problem. There can be just one root cause or there can be multiple root causes. There can be one criminal behind a crime. There can be a group of criminals behind the crime. Possible, yes or no?
Yes.
So, this you have to think in this manner if you are really concerned about the root, fixing a root cause. This is known as root cause analysis. All of you are with me on this?
Yeah.
Yes.
Very good. And so the first requirement towards fixing a root cause is identifying the root cause. Identifying the root cause. See, you can identify the root cause out of your experience, nothing wrong. Because we are talking about the subject of coffee, and we're all experts in coffee. Even though we don't make coffee ourselves, we still know how coffee is made. Yes or no? We have the enough expertise to talk about the coffee making. Similarly, who is making your product? You and your people, yes or no?
Yes, sir.
Don't look for the expertise, first of all, outside. There itself, we are making a big mistake. Your product is made within your factory, within your facility, isn't it? Your service is offered from your place. And you and your team actually delivers all of this. First of all, you must know all the X involved in your process. You must familiarize yourself. That is called the experience. Otherwise, your experience cannot help your company. Particularly cannot help in solving any problem. If you don't know anything about the X, how can you be involved in solving a problem? Agree, all of you?
Yes.
Some homework, some kind of teamwork, some kind of brainstorming definitely required to list down all the X. And then when it comes to the why, you should drill down to the level of CTQs. You can't simply say
அப்படியே பின்னாடி இல்லைங்க அர்ச்சனா இருக்குல்ல பின்னாடி இல்லைங்க
quality is the ocean, customer requirement is the ocean. What are you right now concerned about? Are you concerned about Y1? Are you concerned about Y2? Then only you can make a progress. And now already I told you the sugar is responsible for the sweetness. In order to fix the problem related to the sweetness, let us say the coffee is not sweeter enough. You know that sugar is the root cause. You know that sugar is critical to sweetness. And sweetness is not enough. What will you do? Will you increase the sugar or decrease the sugar now?
Increase.
Increase the total.
You increase the sugar. If you increase the sugar, what will happen to the sweetness?
It will increase.
So can you see a relationship between amount of sugar and the sweetness? Sweetness is your Y, sugar is your X. If I increase the X, my Y is going up. This is called positive relationship between a factor and your Y. If the factor is the root cause, in order to fix the root cause, you should first of all know the relationship between the root cause and your Y. All of you understand this particular point? If you want, see, adding sugar is the solution, yes or no?
Yes, sir.
Adding sugar is the solution. Sometimes people call it a treatment. I give a treatment, then patient recovers. The equivalent word is solution. So the secret behind solution is knowing the relationship between X and Y. Knowing the relationship between X and Y. What is the relationship? What will happen to my Y if I change the X? This is the answer for the relationship. Relationship can be positive, relationship can be negative. Positive means increasing the X will increase the Y. Negative means increasing the X will decrease your Y. If I consume more calories, what will happen to my body weight?
Increase.
So calories
It will
has a
increase.
positive relationship. Calorie consumption has positive relationship with our body weight. If I do more exercise, what will happen to my body weight?
It will reduce.
Reduce, isn't it? Now you can see a negative relationship here. This piece of information is essential to talk about solution. Am I right?
Yes.
So root cause analysis means identify the root cause, then study its relationship. Study its relationship. Then one more thing you need to do. Ensure how many root causes are involved in the problem. Is it just only sugar is the problem? Or coffee powder is also a problem? Or milk is also a problem? There can be a scenario where multiple root causes can exist. Yes or no?
Yes.
So you need to figure out, what is the contribution of a particular factor for a particular problem or particular deviation in the Y. Any problem with respect to the sweetness is completely contributed by the sugar. Am I right?
Yes.
Because sweetness
Yes.
doesn't come from milk, sweetness doesn't come from the water you add, sweetness doesn't come from probably the coffee powder or whatever. Sweetness is derived completely from the sugar. So there is only one root cause which can affect the sweetness in the coffee. But normally with respect to other products and other scenarios, there can be multiple factors affecting a particular characteristics of a product. Let's say strength of a concrete block. The compressive strength of a concrete block is under trouble now. Now, which is the factor that is affecting affecting the compressive strength of the concrete block? Which has gone wrong? See, we all very well know to make the concrete block stronger, there has to be cement, there has to be sand, there has to be some reinforcement, there has to be some water, there has to be some additional ingredients. Yes or no?
Yes.
But for the current problem is we normally get a particular amount of strength, compressive strength. all of a sudden in a particular batch, the strength has, dropped. Now, which particular ingredient has gone wrong? That particular ingredient is the culprit. Yes or no? Suppose if
Yes.
water is not added in proper quantity, then that is the culprit. Suppose if cement is not added in proper quantity, that is the culprit. Suppose both the cement as well as water, both are not added in right quantity, there are two culprits now. Can you see that?
Yes.
So this is the scenario of multiple root causes. If multiple root causes exist, what is the contribution of each root cause? I mean, you need to find out which is the major contributor. How much trouble is caused by water and how much trouble is caused by cement? Can you give a percentage? Oh, 70% of the problem is because of the water and 30% of the problem is because of the cement, or vice versa. I don't know. This piece of information is also required before developing solution. All of you agree with me?
Yeah.
Yes.
For that purpose only, most of the time you all search for the SME. Who is SME? Subject matter expert. But please note, problem has happened within your factory. Yes or no? When there is no point of searching an SME outside your factory. The SME has to be identified within your factory because all the subject matter experts outside, they only know the theory. The real problem you only know. Yes or no? So now there is a way by which you can convert yourself into a subject matter expert. There is a way you can convert yourself into a subject matter expert. It is nothing but you must start conducting some experiments. How can you convert yourself into an SME? You must start conducting some experiments yourself. If you start conducting experiment yourself, you get to know which are all the critical factors. You get to know how much influence each critical factor has got on your why. All of you agree with me on this? If you get answer for all these kind of questions, trust me, you will the best person to develop a solution to a particular problem which your company is experiencing. What are the answers needed? Identify the root cause first. Then study the relationship of the root cause. Then the third one, contribution, percentage contribution of each of the root cause. This is known as sufficiency of the root cause. All this together is known as root cause analysis. Identification of the root cause, and then before relationship, validate the root cause. Identification means just based on experience, people telling, but you must verify it experimentally. If you verify it experimentally, validation happens. Identification of root cause, validation of the root cause, relationship of the root cause, and finally sufficiency of the root cause. These are the 4 stages in root cause analysis. If you know this, you can fix any kind of problem, no matter however complex it is or however
One second, these 4 phases. Identifying the root cause.
Then validating the root cause.
Okay.
Identifying the root cause, validating the root cause, studying the relationship. 4th one, studying the sufficiency. Sufficiency
Studying
means sufficiency.
Okay.
Sufficiency. That means how much influence each root cause has got. These 4 questions, if you can answer well, you can proceed to you can proceed to the development of solution. Otherwise, you may not be able to develop a perfect solution to the problem, right? So this is called process thinking. Now this thinking can be applied to any kind of product, any kind of problem in any kind of product. Now what is the product you are seeing in my screen?
Laddu.
You all like laddu, I know, right? So in laddu, are there any CTQs applicable for a laddu?
Yes.
Tell me.
Amount
come on.
of sweetness.
Sweetness, very good.
Size.
Taste.
Size.
Size. Size means you have to somehow measure it.
Weight.
How can I measure the size? You
No,
can
it shouldn't
measure
be
it.
like that big, as in Tirupati.
Quant-
You can measure probably the diameter of the laddu because it is circular in a spherical. You
Yeah.
can measure the diameter. You can measure the weight of the laddu, the color of the laddu, isn't it? And the sweetness you already mentioned.
Texture of the laddu.
Yeah, texture of the laddu. And the strength with which each particle of the laddu, the bundi, isn't it?
Freshness.
Stick to
Binding.
each other. Do you think the strength of each bundi sticking to each other is also important while selling laddus?
Yes, it is.
Otherwise, before you deliver, all the laddu can become a bundi, isn't it?
Yes.
So everything you should be in a position to measure it if you want to be successful in the market.
Yes.
Agreed, all of you. You can't say, sir, what is this here? Why should I, measure the, adhesive strength and this is not a paint or something. This is laddu. No, you're wrong. If you can't measure certain characteristics of your product, that can become a big reason for failure of your product. If you are making laddu just for your family, no problem. You don't have to measure any of this. But if you want to make and sell millions of laddus in the market, then you have to measure everything. Agreed, all of you? Agree, all of you?
Yes.
Very good. Right? So CTQs are very, very important. Knowing the CTQ is very, very important to succeed in any business. Right? And then you must measure the CTQs while making a product or while offering a service. And if there is a problem with the CTQ, definitely there is a problem with some X. Yes or no?
Yes.
If the laddu is, collapsing immediately, when somebody picks your laddu, immediately it is collapsing. Then what is the problem?
Binding.
The binding strengths. So binding material. What is the binding material you added in your laddu? Have you
Sugar.
added Fevicol?
Sugar.
Yeah.
No, you added something, right? Some kind of, maybe solution you added, maybe in a eatable manner. So you need to think about it and do some experiment there. How much quantity is needed per laddu? Is that 2 ml will do, or 3 ml will do, or 4 ml will do? Do some experiment, then you get the solution. Yes or no? You don't have to look for, the solution from outside. You can develop the solution. This thinking, I want all of you to apply while solving any kind of problem, particularly while solving complex problems. Clear?
Yeah.
And now the process improvement approach, all of you are very, very clear. Process effectiveness, process efficiency. Process effectiveness means defect-free product. Process efficiency means waste-free operations. We started 7 o'clock, right? Now 8:20. How many minutes? 60 plus 20,
80.
80 minutes. Are we productive all the 80 minutes?
Yes.
No.
Yes.
Then only we can say, no, we are waste-free. Suppose every time if I ask a question and I have to wait for 10 seconds to receive a reply from your side, that 10 seconds is a waste. Yes or no? And you ask me a question, I give a wrong answer. Then that is a demonstration of an ineffectiveness. Isn't it? You ask a question
Yes,
and then
sir.
I give a wrong answer. That's a non-conformance. That's a defect, isn't it? So
Yes.
in process thinking, the definition about the effectiveness, the definition about the efficiency is very, very important. It is the ineffectiveness which causes defect. It is the inefficiency which causes the waste, isn't it? So Six Sigma will try to eliminate the defect and Lean will try to eliminate the waste. Both cannot be compromised in any business process, right? Effectiveness cannot be compromised and efficiency should always be optimized. See, which is of a major concern from the customer's standpoint? Effectiveness is a major concern or efficiency is a major concern?
Both.
Both are measured.
Do you think the customer will worry about how difficult it was for you to make a laddu?
No, sir.
No.
No.
Customer will not bother how do you make the laddu, but customer will bother only about the taste of the laddu.
But delivery
So
will get affected.
effectiveness is a major concern for the customer. Efficiency is a botheration for the business.
Process.
Of course, for the business, both are important. For the business, both are important. But for the customer, the effectiveness is very important. The quality is very important. But for the business, productivity is also equally important. Agree, all of you?
So for
Yes, sir.
customer also, on-time delivery is important.
See, if the on-time delivery is also becomes a customer requirement, then that becomes a dimension of quality itself. Isn't it? Suppose, if it is let's say a delivery service, then on-time delivery is the customer requirement. That is it is observed in the quality itself.
Then
All right, but
efficiency will be
true. See, if you are not efficient, that will affect your effectiveness. That's why I told you there is an interrelationship. If you are not efficient, that can become a reason for your poor effectiveness also. If you are not effective, that can be a reason for your poor efficiency also. They are interrelated to a certain extent. At the same time, you should be able to differentiate them. All right. Now going back to the history. You see 3 people on the left side and 3 people on the right side. The left side people are the Japanese architects, architects behind the reason for Japanese quality, particularly Toyota production system. Eiji Toyota, Taichi Ono, Dr. Shigeo Shingo. On the right side, there are 3 people. First one, the CEO of Motorola, Robert Bob Galvin. The second one, the engineer inside Motorola, Will Smith. Third one, the statistician inside Motorola, Dr. Michael Harry. So they are the architects behind Six Sigma approach. These 3 are the architects behind Toyota production system. Today we call it as lean. In some literature, the TPS is referred as Kaizen model. Because Kaizen means continuous improvement. Because
Japanese word.
it's a Japanese word, Kaizen. But because the Toyota production is, strongly believing on the continuous improvement model. It believes in process approach. It believes in continual improvement of the process. If you continually improve a process, you know what will happen over a period of time? Process will start delivering defect-free outputs in a waste-free manner. Agreed, all of you? If you continually improve, if you have the habit of standardizing your lifestyle, and then you make small improvement every day, after 6 months of time, you will see, yourself leading a very, very healthy lifestyle. Yes or no?
yes.
So this is the power of continual improvement. So Kaizen means continuous improvement. It's a Japanese word, changing for the betterment. But the model was modified to suit the requirement of Toyota. And they developed a model applicable to Toyota because Toyota is a car manufacturing company. Their initial market is within Japan. Later on, they in fact, started selling it, across the globe. Initial market is Japan, which is a small market. And any customer would like to have multiple variants in a particular type of car. Yes or no? We want cars in different colors, different variants. So this is the requirement. To cater to this kind of requirement, the Toyota, they developed a model to meet this requirement. They named it as Toyota Production System. The entire Toyota production system is built on 3 things. One is process standardization. The basic one is process standardization. And then another important thing is, when process standardization should be considered the foundation. And then there are 2 pillars. One is right sizing the resources. What is the word I am using? Right sizing the resources. What do I mean by right sizing? Providing the resources only in the required quantity. You remember when you are sending, your kids to the school, you give pocket money, yes or no? How much pocket money you would like to give them? You want to give them more money or less money?
Yes.
Correct money.
Just required money.
Required money, yes or no?
Yes.
Because you don't want to give them a chance to misuse the money, yes or no? Because money is needed for the requirements. So you are giving, but you don't want to see them misusing the same. Same is the logic, followed in developing Toyota production system. What is it known as? Right sizing the resources. That means the idea is providing the resources only in the needed quantity where the resource is required and when it is exactly required. Do you understand? That means they wanted to produce the item only if there is a demand. Do you understand? This is known as just in time. Just in time production. The bigger vision behind just in time is trying to operate the entire manufacturing process with zero inventory. Clear, all of you? One important pillar of Toyota production system is right sizing the resource. Another important pillar. See, by providing the right amount of resources, what are you assuring? You are actually preventing the misuse of the resources or excessive consumption of the resources because you are not giving anything in excess. If you are not giving anything in excess, how can they consume? If somebody wanted to consume, then automatically, it will get, escalated. If you give the right amount of raw material, suppose if the raw material is wasted in a particular section, you know what will happen? They will ask for extra raw material. Then they have to take an approval, yes or no? If they have to take an approval, it gets monitored to the higher level, yes or no? The problem is automatically coming to the surface just by respecting a principle known as right sizing the resources. Can you see that, all of you? This is the advantage. So right sizing needs to monitoring, effective monitoring, yes or no? So another important pillar is self-monitoring. Every resource will have the ability to self-monitor its conditions. If at all any abnormality is noticed, the resource will identify the abnormality by itself and then the process will get stopped, either manually or automatically. Do you understand? Say, for example, in your car, the dashboard is provided. You know why the dashboard is provided? The dashboard can tell you whether fuel is available in the car or not. If the fuel is not available, can you see a red color indicator glowing? The resource itself identifies an abnormality and then, it will give a warning signal. So first thing you will do is you will take the car to the nearest petrol pump and then feed the petrol. So likewise, every machine should be equipped with an ability to detect abnormality. Isn't it? Whether it's a machine condition or during the production process, if something goes wrong, the system, the line itself will detect the abnormality. If somebody feeds the product in a wrong direction, then the system will detect it and then, salt the line, stop the line automatically. This is called self-monitoring. All of you, do you understand? The entire Toyota production is based on these two pillars and the foundation. What is the first pillar I said? Right sizing the resource. Another pillar is self-monitoring. Self-monitoring can ensure the quality is achieved. Right sizing the resource ensure the productivity is achieved. The planned quality is achieved and the planned productivity is achieved. What else you want? Isn't it? The planned level of Quality, the plant level of productivity is, the quality is built as part of your system, as part of your process, right? And then this is supported by a strong foundation of standardized process. Work should not happen, the way the operator decides. The work must be performed as per the process, standardized process. So this is known as Toyota Production System, just to ensure the organization moves towards a state of just in time. To ensure the organization achieves an effective monitoring in place, so many tools are developed to achieve that. Tools like cycle time, takt time, all of this, can help you to SMED, single minute exchange of dice, and Kanban, pull system, continuous flow. All these things, ensure your productivity gradually improves. And then finally, you will achieve a state known as just in time. Similarly, tools like Fibers, visual control, visual management, Poka-Yoke, all of these things, will ensure monitoring, better monitoring in place. And this has really, gave a fantastic result for, Toyota. And then their products have become very, very popular because they were able to produce, best in class cars. You know the quality of Toyota cars, all of you. I don't have to explain, isn't it? And slowly what happened? The Japanese products, particularly the cars, started, dominating in the market, and because of which the Americans companies started feeling the pressure. In fact, originally the Japanese, they learned a lot of things about the quality principles and quality tools and techniques from the American quality gurus like Edward Deming and Walter Shewhart. And all these quality gurus actually helped Japan, because Japan was hit badly in the World War, you all know, isn't it? And so they have to learn many, many things from the, the best in class companies, particularly Ford. From the, in fact, the Japanese people, they visited Ford and benchmarked the best practices, and that's how they developed the Toyota production system. And this made magic for Toyota. And then people around across the globe, they wanted to copy the Toyota production system and then use it in their company. So they started copying the idea of Toyota production system, and then they gave it a new name, because they can't use the same name because the word Toyota is there. So it was renamed as Lean. You can see the similar setup, being followed by other companies. Bosch has Bosch production system. Some of you might know, isn't it? Similarly, the Mahle group, they have Mahle production system. So companies, they're all modified version of whatever we spoke right now. There has to be continuous improvement. There has to be standardization. There has to be monitoring. Yes or no? There has to be, effective, minimal consumption of the resources. They're all modified version of TPS only, but in general, we call it as Lean. Who are the architects behind this? Eiji Toyoto, Taiichi Ohno, Shigeo Shingo. And out of the three, Taiichi Ohno is the one who introduced the concept of 7 waste. He is known as father of TPS. And Dr. Shigeo Shingo, he is the one who introduced the tools such as Poka-Yoke, SMED, and so on, right? And coming to this side, so see, all these revolutions within Toyota happened during the period 1950 to 1980. And it is considered that, TPS was introduced during the year 1960, right? And then later on, 1980, you know what happened? The Japanese products were really competing well in the market. They were even considered better than the American products. And so to overcome this competition, the Americans, particularly the company Motorola, they embarked on a new approach to overcome the Japanese competition. This efforts gave birth to another unique approach, which they named it as Six Sigma. Here, in the TPS, the idea is waste elimination. But here in Six Sigma, the idea is defect elimination. How? By controlling the variation. In the year 2000, companies started, realizing that both concepts, can be applied in their company, no matter whatever domain they are into. Whether it's a manufacturing company, whether it's a service company, whether it is an accounts department or a sales department or a assembly department or a logistics department or a supply chain, whatever it is, in all areas, all verticals of the business, these concepts can be applied. All of you agree with me? Yes or no? Process thinking, effectiveness, efficiency, they're all required in all areas of the business. Am I correct?
Yes, sir.
So
Yeah.
all companies started, embracing the both lean as well as Six Sigma almost after the year 2000. Companies, started deploying Six Sigma, together, and the new method has born, which is integrated approach, Lean Six Sigma. Prior to 2000, Lean was deployed separately, and then Six Sigma, certain companies following Lean, certain companies following Six Sigma. But now, wherever Six Sigma is implemented, Lean is also integrated there. Wherever Lean is integrated, Six Sigma is also deployed, because one can complement the other idea very well. So from 2000 onwards, the integrated approach has become very popular. We call it as Lean Six Sigma. Now you can see plenty of books written on the topic Lean Six Sigma, simply because they can support each other very nicely. All right. So now I think you know why, the reason behind why companies, use both Lean and Six Sigma, because they have to ensure the quality. At the same time, they have to ensure the profitability. All right. And this person, Bill Smith, the engineer over there, he is considered the father of Six Sigma. See, the Six Sigma is actually culmination of engineering brain and the statistical brain. That is why we are also talking statistics here. All of you can be super successful in your career if you learn little statistics. Am I right? If you learn little statistics, then you can take very, very effective decision. Decision making is an important skill needed for all the managers and leaders, isn't it? So the engineering brain and the statistical brain, the culmination of it gave birth to Six Sigma. All right. And look at the success stories, particularly from the Six Sigma. Motorola, they made a saving of $2.2 billion every year, and $1 billion saving in non-manufacturing. Straight away in the within Motorola itself, Six Sigma was applied in manufacturing departments as well as non-manufacturing departments. That's why the savings are highlighted separately. There is an ABB, Asia Brown Boveri. They witnessed 68% reduction in the defect level, 30% reduction in the production cost, $898 million savings every year through the Six Sigma initiative, Six Sigma projects. And General Electric, by spending $500 million, by spending $500 billion, they got back $2 billion in 1 year, and then $12 billion in 5 years' time. All right. So what do you understand by seeing these results? Six Sigma is actually an operational excellence model, or rather Lean Six Sigma is an operational excellence model, because it can give your organization the ability to outperform the competitors. Am I right? Because these principles, methodology, tools, and techniques, if learned properly and then practiced properly, it can give your organization the real ability, the real chance to outperform the competitors. That means your company can become a market leader, if they could outperform. So as a result, the profitability goes high, the market share goes high, the customer satisfaction goes high. But please note, quality is a strategic priority, right? And here, when we talk about Lean Six Sigma, we are truly concerned about the quality of our products and quality of our services, because you can't simply, optimize everything, by compromising the quality. That is not a great idea. So the strategic focus, quality should never, be a compromise. And in order to achieve these kind of breakthrough results, Lean and Six Sigma must be deployed strategically. How it must be deployed? Strategically. Strategically means don't use Lean Six Sigma just to try one project. It may not work. But use Lean Six Sigma to execute hundreds and thousands of projects across the organization by involving everyone in the organization, involving all the departments. This is called, strategic deployment. Do you understand the difference? If something is planned strategically, it can lead to breakthrough improvement. Otherwise, what will happen? You will produce only small improvement. Clear? See, if you plan for a longer tenure, then say for example, you want to become a billionaire. Can you become a billionaire in 1 year? But 10 years, if you plan something for the next 10 years, there is a great chance. Yes or no? So what I'm trying to say is Lean Six Sigma model can definitely work well if it is executed strategically with a top-down approach. That means it should be driven from the top management. It should be driven by the top management. Of course, the projects we will identify at the down level. However, it definitely needs the support and blessings of the top management. And then what will happen? It can do the magic for any company. And so in order to execute the hundreds and thousands of projects over the next 2 or 3 years, you need people with proper expertise, proper skill set. And so various belt levels are created according to the contributions they have to make in the project. You see there are various belt levels. The first level is white belt. Yesterday around 7:30 we started discussing about Lean and Six Sigma. And now that you have developed some solid foundation knowledge about Six Sigma, am I right?
Yes.
And you started, believing that Six Sigma can produce results in your company also. If answer to my questions is yes, that means you have now undergone the transformation. You can now be called as a white belt because you become a strong believer of Lean, Six Sigma, and the quality principles. It's a science. It should work. Science means what? What? It should work for everyone. Science is nothing but study of the nature, isn't it? Nature behave in a particular manner. Most of the time, you will see the nature behaving in the same manner only. So, this level of transformation is white belt, but this is not good enough to work in a project. To work in a project, you need to elevate you to the next level, which is known as yellow belt. You are now ready to work under the project leaders, who are normally green belts and the black belts. You can work in a project, but you have to be guided by the green belts and the black belts. You must be assisted by the green belts and the black belts. It is like the nurses getting guided by the doctors. Nurses are giving treatment to the patients, but not on their own, as per the advice given by the medical doctors. That is the meaning of the yellow belt. You know the tools, techniques, yes, we agree. You know the methodology, you know the basics, but still, you can't do any project independently. You have to be guided by the green belts or the black belts. So the green belts and black belts are nothing but the project leaders. They can lead a team and drive a project towards success, right? And between the green and black, the black belt will work on complex projects. Green belt will work on simple and moderate projects. The project will become more complex if multiple departments are involved in the project. That means the project is a cross-functional project. All right. And moreover, the difference between green and black is a green belt is a part-time Six Sigma expert, meaning he is expected to complete maximum of 2 projects in a year. But a black belt is a full-time Six Sigma expert, meaning he is expected to complete 6 to 8 improvement projects within a year. All of you, do you understand the difference here between green and a black belt? And then there is another important role. The highest level of proficiency in the ladder of Six Sigma is master black belt. A master black belt is the one who will collaborate with the top management, who will be part of the Apex council or the committee within the company responsible for achieving operational excellence. The committee is normally known as quality council or business excellence or operational excellence, group. You might have seen, heard all these, terms, departments, inside certain companies, right? And definitely MBB will be a part of such council or committee, and his role is phenomenal in ensuring, in developing directions for the company. In developing directions, in which direction our company should progress for the next 3 years. I'm not saying that MBB does everything. No, he is part of the committee. And the committee has to work very closely with the top management to understand the vision and mission of the company. And then break down the vision and mission into clear-cut direction to the leaders within the company. The top line leaders, they should know the direction. Then what will happen? They will give direction to the mid-level leaders, the middle management. And then the middle level leaders will give directions to the down level managers. The activities performed at the down level are known as the operations, isn't it? And in order to understand whether the company is moving in the right direction or not, certain metrics are essential. All of you agree? If there are no metrics, we don't know whether we are progressing in the right direction or not. So certain metrics are developed to understand whether the company is moving in the right direction or not. Those metrics are known as KPIs, key performance indicators. All right. So for the top management, the KPIs are known as strategic KPIs. For the middle management, the KPIs are known as tactical KPIs. All right. And for the downline managers, the KPIs are known as operational KPIs, which means there are 3 levels of goals: strategic goals, tactical goals, operational goals. The tactical goals are nothing but annual goals. Operational goals are nothing but the quarterly goals, the monthly goals, the weekly goals, the daily goals, and the daily targets. Can you see here a bigger goal is broken down into daily activities? Can you see that? Because the KPIs are derived, from each other. Practical KPIs are derived from strategic KPIs. Operational KPIs are derived from tactical KPIs. And then your quarterly target and weekly target and the daily targets are derived from your operational KPIs only. This is called goal alignment. This is how we need to synergize. So knowingly, unknowingly, directly, indirectly, everybody contributes to the organization's bigger objective. All right. So the role of the quality council or the Apex steering committee is very, very important, where the contribution of the MBB will be phenomenal. And so he will earn the recognition. He will earn the biggest compensation. You can't imagine. So they will definitely, everything will be definitely beyond your imagination. So try to become one such MBB. For that, you have started your journey today. All right, white to yellow, and then yellow to green, and then green to black, and then you can convert yourself into black to master black belt. And once you become a master black belt, you can also train. You can also conduct trainings internally within your company. And then whatever number of belts required, you can produce, and then you can add them in the project team, and then only they can actually work in the project. Without proper training, it is very difficult for someone to work in a DMAC project or a Six Sigma project. All right. And it's not the end. You also need the top management involvement so that the projects can actually deliver result. So there are 2 roles created in every project team. One is known as project champion. Other one is project sponsor. The project sponsor is nothing but the top man in the company who has the authority to approve any project and provide the resources. All right. It can be department head, or it can be the managing director, or it can be chairman. It depends on the company. So whoever is given the power to exercise the approval, then he is the project sponsor. Since he is a busy man, always there will be a champion. The champion will be liaising between the sponsor and the project team. Whenever the project team is going through any kind of struggle, the champion will immediately be the immediate point of contact, and then he will resolve the issue. Can you see a good infrastructure of people getting formed so that this group of people can ensure the company executes all required projects in a proper order, and then after 2 or 3 years, the company will feel the transformation. The company today and the company after 3 years there will be drastic improvement. Can you see that, all of you? This kind of infrastructure needs to be created if you want your Six Sigma deployment to be successful in your company. All right. And definitely it requires the support of the top management and then some investment, because so many people have to be trained. It's not just you can bring all the necessary transformation. Just one person cannot do anything. Everyone has to be involved, right? And see here, all the responsibility are highlighted here also. You can read all of these things and from the slides. So I would like to give you a break here because it's around 8:55. So shall we take a
Can you
break
go to
here?
the previous slide, please? Can you go to the
I
previous
want to
slide?
go to the previous slide.
Yeah, please.
This one.
Yes, yes, yes.
Yeah.
Correct.
This I have explained separately. And so that's why, I asked you to go through the slide yourself. The responsibilities
sir.
are highlighted.
Thanks.
All right. So we'll take a break here. So maybe 10-15 minutes. So by 9:10, please come back. We'll continue.
Sure, sir.
Yeah. Are we going well?
Yes.
You are
Yes,
following me? You are able to travel with me? Or how many of you are getting disconnected? All are able to follow, right? So
Yeah,
any
yeah.
questions? Any questions based on the terms we discussed so far?
Professor, you told about the three goals, strategic goal, operational goal, and what is the other goal? I just missed the term.
Strategic goal
The second one,
and
the
the middle
tactical
Regarding
goal.
the KPIs.
tactical goals,
Tactical.
and
Okay,
finally the
okay,
downline is operational goals.
Yeah. Okay, got it.
So certain leaders will be responsible for the down level goals, operational goals. Then the mid-level managers, tactical goals. Then the top line managers, strategic goals. Now it is very important you connect their goals so that all of them can travel in the same direction. So your organization can achieve the objectives as early as possible.
Sir,
We discussed about it under the 7 habits, synergizing. Yeah. Fatima, you want to ask something?
yes, sir. Why we call it Six Sigma?
Why it is called a 6 Sigma, right? Okay. Okay. So you have to wait because this answer requires, a detailed explanation. The answer to the question is already yesterday I gave one definition for Six Sigma capability, isn't it? The failure
Yes.
should be very, very minimal. Failures must be rare. What is the metric? DPMO. If the DPMO is 3.4 and below, then the capability is known as Six Sigma capability. Clear? One more definition. The success rate. Let us talk positively, not the failure rate, success rate. The success rate must be in the order of 99.999%. If you have a process which can assure a success rate of 99.999%, then you can say the performance is Six Sigma performance. Now, another definition is also clear. Am I right? I know your concern is statistical definition because Sigma is involved, right? What is Sigma? Standard deviation. What is Sigma? Standard deviation. See, always customer gives a target for all the CTQ metric. Agreed?
Yes.
Strength of the material should be, let us say, they will declare the compressive strength should be 100 plus or minus 5 kg per millimeter square. Now, what is the target? 100. What is the upper limit? Plus or minus, how much I said? Come on, yeah, plus or minus 100 plus or minus. What is the value I mentioned? tolerance, any tolerance that customer gives, isn't it? 100 plus or minus 5. So what is the upper limit here?
105.
105. Lower limit is 95.
95.
If the compressive strength is anywhere between 95 and 105, customer will buy your product, will accept your product. That is the agreement. Now, what should be the compressive strength of your product? Do you want them to be just inside 95, 105? Or do you want them to be closer to the target? Which is a good idea?
Closer to the target.
Closer to the target. If all your products are closer to the target, then the distance of your product from the specification limits. What are specification limit? The tolerable limits of the customer. 105 is upper specification limit, 95 is lower specification limit. Then if the distance of your product from the nearest specification, you need to measure. Do you understand what I'm explaining?
Yes.
All right. See, if you know that all your products have, let us say all your products have a compressive strength of, between 100 and 102. 100 and 102. But what is the nearest spec? 105. What is the nearest spec? 105, isn't it?
5.
And now you very well know that your process is centered around 101. Because I said the process is operating between 100 and 102. So the center point is 101. You have to carefully listen to me, right? You understand the customer requirement, 95, 105, target is 100. But where is your process operating? Between 100 and 102. So your process is centered at 101. Now my question to you is, your process is centered at 101, but the nearest tolerable limit is 105. What is the distance between the two? 101, 105. What is the distance?
4.
4 units, 4 kg per millimeter squared is the distance. Isn't it? 4 unit away from the nearest spec. Now this 4 units, you have to, express in terms of number of standard deviation. In terms of number of standard deviation. If see, when I say 160 rupees, it is equal to $2 US. Yes or no? Because assuming 80 rupees is $1 US, then 160 rupees is $2 US. 240 rupees, $3. Yes or no? 800 rupees will be $10. Similarly, the 4 units distance, you have to express as a number of standard deviation. Like the number of US dollars, you have to express number of standard deviation. For that, first of all, you should know what is standard deviation. You all have studied in the school. Am I right? How many of you remember? So we have to recall, right? So we have to recall. So if you know the value of the standard deviation, you can find out how many standard deviations equals this 4. You get my point? Suppose if the value of the standard deviation is coming out to be 2, then how many standard deviations equals this 4? I think all of you started sleeping, right? If the standard deviation is 2, then 4 can be equated to 2 times standard deviation. Yes or no?
Yes.
In this case, the process will be called as a 2 sigma process. I know it is difficult for you to understand. So wait for, that's why I told you, just wait for the particular slide to come, then it will be all clear. Anyway, since you asked the question, I don't want to disappoint you. I gave some response, some answers. If you have understood, well and good. Otherwise, just wait, right? It will be clear. So recording is going on. So
Sir,
let us continue. Yeah.
there was you were discussing regarding this root cause. So there were 4 points: identifying the root cause, validating the root cause, and another 2 points. Can you just come again with That 2 points.
Studying the relationship of the root cause with our output variable.
Okay.
Then the fourth one, studying the sufficiency of the root cause.
Okay.
Sufficiency means how much contribution comes from each root cause. The total problem is 100%. What percentage of the problem comes from the first root cause? What percentage comes from the second root cause? If there is a problem within the family, it is because some of the family members are troubling. Yes or no?
Yes.
Yes.
And now if two members of the family are troubling, who is the major troubling source? You wanted to know, isn't it? Because you need to take action there first. Then who is the next contributor? Same manner, if there are multiple root causes, how much contribution comes from each root cause? Because these pieces of information are essential to think about the solution. Yes or no? If
Yes.
all these informations are available in your table, you can think and talk better about the solution, and hence you can develop a beautiful solution. That is the idea.
Yes.
Particularly when the problem is complex in nature, you need answers for all these questions. If the problem is not complex, you have handled it so many times earlier, then you don't have to do anything. Straight away, you might know the solution. But however, we just call it unsystematic. But systematic means you have to go through all of this. Okay. Now comes the slide. What is Six Sigma? The definition says Six Sigma is a management philosophy to meet your business objectives by reducing variations. Because we know the science behind variation, isn't it? If variations are reduced, effects will automatically get reduced. If everything goes as per the plan, there are no deviations, yes or no?
Yes, sir.
So you just have to check whether everything is going as per the plan, whether everything is as per the expected range. That means you control the variation, problems will vanish. Six Sigma is a disciplined data-driven methodology for decision making and process improvement. See here, all of you, ladies and gentlemen, here, any process by nature, it will demonstrate a particular pattern. All of you agree with my statement? Any process by nature will demonstrate a particular pattern. For example, if I collect all your age data, will there be a pattern? What do you think will be the average age of the participants here? What do you think will be the average? We have not seen all your faces, right? But still, let us make a guess.
5 to 40.
30.
30.
40. So let us say 35.
28.
Because I'm taking average. Because average can always help you to understand, the majority of the participants. So 35. If the once we realize, see, we can easily do an exercise. I can collect all your age, put it in Excel, and then calculate. Once I know the average is 35, approximately half of the participants will have an age above 35. Is my understanding correct?
Yes.
Another half will have an age below 35. If everybody comes on the video, we can make a guess, isn't it? How many are above 35 and how many are below 35? And you will be surprised to see, more or less, half of the participants will be above 35, half will be below 35. Am I correct?
Yes.
That is getting demonstrated here in the curve. Can you see a bell curve? If I draw a line at the center, half of the curve is on the right side, half of the curve is on the left side. Can you see that?
Yes.
The center line is nothing but the process average. What is the center line? Process average. The moment you know the average is 35, if you ask everybody to come on the video, you will see majority of the participants having the age closer to 35. Am I right? But right now, only senior people are on the camera. I could understand, isn't it? But then if everybody turns on the camera, can you see more people around the age of 35? Is my understanding correct?
Yeah.
That is the reason why you see the curve taller around the center. Can you see the curve taller around the center?
Yes.
Who is the youngest participant here? Who is the youngest participant? One student introduced, isn't it? Who is- Yeah, you are 19, right? How many people are closer to the age of 19 here? Very few. Yes or no?
Yes.
19 is below the average. You see, you come below the average. Can you see the curve coming down, dropping down to touch the x-axis? That means there are not much people beyond the lower value. Yes or no? That means the curve can go to the maximum of the minimum value. And beyond the minimum value, there are no participants. Even in the next program, when I conduct, it is very, very rare to get a participant with an age less than 20. Yes or no?
Yes.
That is the inference. This is the nature of my process. Normally, for the Six Sigma training program, people to join the Six Sigma training program itself, certain level of maturity is required. Even people with 1 or 2 experience only, they talk about Six Sigma. That's why I appreciated that particular, candidate yesterday. Very good. Similarly, the maximum age, maybe, somebody might be around 50 or 55. Am I right? That means that means 55 is above the 35. If I move above 35, and I understand here the maximum age of the participant is, let me say, 55 or something. All right. That means only very few people are having the age around 55 and above. So beyond 55, the curve is, almost touching the x-axis. Can you see that? Why I'm saying that it is almost touching the axis, it will never touch the x-axis. We don't know what will happen in my next batch. I don't know. Another student with the age of 18 might join my next batch in the next batch. A candidate with the age of 65 might join my next batch. Yes or no? Possibilities are there. That's why, we always say the curve just come and then come close to the x-axis, it will never touch. And now I understand the nature of my process is in every training program, we get participants between the age of, let's say, 20 and then 55. Is my understanding okay?
Yes.
So my target audience is, age group 20 to 55. Majority around 35. Not only this batch, if I go to my previous batch, almost similar scenario. If I go to my next batch, almost similar scenario. Because the batch is, naturally created. Yes or no? Do you understand? All of you joined on your own. We have not picked up, we don't have the chance to, pick up the participant. You all joined yourself. This is called a natural process. Any natural process will have an average, will have a maximum, will have a minimum. All right? Half of your data will be between the average and the maximum. Half of your data will be between the average and the minimum. What is the difference between maximum and minimum? Can somebody tell me? In statistics, we call it the range. Yes or no? The range is an indicator of the spread of your process. Can you see the spread of this process and compare against the spread of this process where the spread is high? The spread is high for the right side process or left side process? Where is the spread
Left
high?
side.
Left
Left
side
Left side.
process.
That
Yes.
means in the left side process, variation is high.
Yes.
If the spread is high, range is maximum minus minimum. So you can understand the variation in your process by measuring the variation. One way of measuring the variation is calculate the range. What is the formula for range? Maximum minus minimum. So the spread more means variation is more. If variation is more, you have poor control over the process. Am I right? You have poor control over the process. Whereas here, you have good control over the process. Now customer comes, he says, I want this value. He can draw the line wherever he wants. Yes or no?
Yes.
There is no compulsion that customer should pick up his requirement according to your process. No. You have to develop your process according to the customer requirement. Now imagine customer says the target or places the target exactly at the center of the process. This is a good scenario for you. Yes or no? And customer draws a line, upper line. You see here, upper specification limit. Can you see here? This is lower specification. See, once customer declares the target, customer declares the upper limit, and the customer declares the lower limit. You understand you understand, the requirement. Imagine customer requirement as a road. A road will have a center line, and road will have a spread. Yes or no? Now your process is like a car. You have a road and you have a car. Now you need to drive the car on the road. Now what is important? Your car must be smaller than the road. Yes or no?
Yes.
If your car is not smaller than the road, if your car is bigger, will you be able to take the car on the road?
No.
Definitely, no. Your car cannot enter, isn't it? So same will be the scenario. The left side, your car is bigger than the road. Can you see that? So this car will definitely get damaged if you try to drive the car in this particular road. Agree with me, all of you?
Yes.
These damages are nothing but the failures, nothing but the rejections. Rejection will certainly happen if your car is bigger than the size of the road. But coming on to the other side, there is a road and you have a very small car like a Maruti 800. Now you can drive the car very comfortably in the road. Yes or no? You will not meet with any accidents and then you will reach the destination. Absolutely no scratch, nothing will happen to your car. Entire car is safe throughout the journey. What is the reason? Your car is smaller compared to the size of the road. This is how you must check the capability of the process. In order to know the size of the car, you must visualize your process. Understand? All of you agree with me? Now, if you collect some data from the process, visualize the data, then you get to know the size of the process. All right? If you collect data and plot a graph, the graph is known as histogram. The graph is known as a histogram. And now by plotting a histogram, you get an idea about the spread of the process. The spread, it talks about the size of the car. And the distance between upper spec and lower spec is the tolerance given by the customer. Do you understand all the terminology I'm using? The distance between upper spec and lower spec is known as what?
Range.
Customer tolerance. But the distance between the maximum and minimum in your process is known as the spread of the process. If the spread of the process is smaller than the tolerance given by the customer, your process can produce defect-free results. Your process can produce defect-free output. Otherwise, definitely defects will be there. All of you agree with me? So, also please note, in statistics, one way of measuring the variation is range. Another way of measuring the variation is standard deviation. You all have studied, right, in 7th standard. I'm sure you all remember now, right? You recollect the standard deviation. Square root of summation of x minus x bar, the whole square, divided by n minus 1. That is the formula. So standard deviation is a measure of variation in your data. In order to calculate standard deviation, you must use all the data points. You remember your calculations you made in 7th standard? All the data you have to tabulate. Yes or no? But for calculating range, how many data points you used? Come on, you need to speak now. How many data points you used to calculate the range?
Two data points.
Only two data
Maximum,
points. You
minimum.
have not considered other data points. So range is not a better or a good indicator of the variation because it doesn't consider other data. So that's why standard deviation should be considered as the best measure of variation. There is a relationship exists between range and standard deviation. I will tell you that. Range is equal to 6 times standard deviation. Range is equal to? Yeah, range is equal to 6 times standard deviation. So now what will I do? I will just stop this. and then I will take a whiteboard so that I can write something you can better understand. See here, this is the road. This is the road. What is this end of the road? Upper specification. Left side, lower specification. So customer target is here. Now you got a car, right? You got a car. Now your car is ending here. Yes or no? The end points of the car. All of you understand?
Yeah.
The end points of the customer limit are known as upper spec, lower spec. Similarly, for your process, we give it a name, upper control limit or lower control limit, meaning always your process will produce parts within the control limits. And this is the spread of the process. Am I right?
Correct.
And we either call it range or you can call it Six Sigma. All right? When I say Six Sigma, when I mark the center of my process, this distance will be how much? 3 sigma. This distance will be how much? Another 3 sigma. Why I am dividing exactly? Because my process is symmetrical. Always, any process by nature, it will be symmetrical at the center. You see your face. You draw a line at the center of your face. Can you see symmetry here?
Yes.
Isn't it?
Yes.
Because it's it's a naturally developed face. Yes or no? So you see a symmetry. So now tell me, can you drive this car safely in this bigger road?
Yes.
So this process is considered a capable process. Capable process means it will produce defect-free outputs. All right. Now I will take you to another scenario. There is a road and there is a car equal to the size of the road. There is a road, there is a car. Both are equal. Now tell me, can this car go inside the road?
It can go, but
can.
It can go, but driving
But
is
the
very
critical limit
challenging.
and the specification limit are the same.
You have to be extremely careful while driving the car in this scenario, isn't it? It is very challenging. Though it looks capable, and in reality, it is difficult to maintain the conditions. So this is your upper spec, and this is your lower spec. This is the target, and this is your upper control limit. This is the lower control limit. Here is your process average. All of you, do you understand everything?
Understood.
This process, if I ask you whether it is capable or not capable, it is just capable. It is not bigger than the road. At the same time, it is not smaller than the road. It is equal to the size of the road. It's not a good idea. Am I right? It's not a good idea to maintain this kind of condition while, driving a car. So now, what will be this distance? Can somebody tell me?
3 sigma.
Oh, very good. You are very sharp. What about this distance?
3 sigma.
3 sigma.
So if you run your business process in this condition, then your business process is considered to have a 3 sigma capability. All of you, do you understand? What is 3 sigma capability? Your process is centered on the target and the control limits overlap with the specification limit. Clear, all of you? What is the capability? 3 sigma capability. What is the capability? 3 sigma capability. Now this is the road. Let's say the width of the road is, let's say 20 feet. What is the width of the road? 20 feet. Now you have a car. Your car is just 10 feet. Your car is 10 feet. Now your car is half the size of the road. Am I right?
Yes.
Now your process is doubly capable. Your process is
Applicable.
doubly capable. That means you have some additional tolerance remain unconsumed. Can you see that? Yes or no?
Yes.
Yes.
Customer has given a tolerance of 10 on the right side, 10 on the right side. But how much your process consumed? Only 5 on the right side and 5 on the left side. So how much remains? Half of the tolerance remains unconsumed. That is why I call it doubly capable. All of you understand? Earlier you told me this will be 3 sigma, right? Yes, sir. This will be 3 sigma, isn't it? Because any spread of any
Yes.
process is 6 sigma. If this is 3 sigma, what will be the balance? That will be another 3 sigma, isn't it? Can you see 5 here and 5 here? Understand, all of you? Or
Yes.
otherwise, the distance between the center of the car and the end of the road is 6 sigma. Now your process is doubly capable. Otherwise, your process is a 6 sigma process. Your process is a 6 sigma process. And now, what is the chance that some accident can happen if your car is half the size of the road? Very, very less chance. Am I right? 99.999% of the time, your car, you will be riding the car in a safe manner. All right. This is 6 sigma capability. However, in a previous scenario, just capable scenario, in just capable scenario, this is your car. Oh, sorry. This is your car, and here is the specification. Can you see your process consuming all the tolerance? The process is consuming all the tolerance, isn't it? So this is the target. Though the spread is 6 sigma, you have 3 sigma on the right side, 3 sigma on the left side. Here, the success rate is 99.73%. A small percentage of the process can go beyond the spec. All the unit here will get rejected. And what is the success rate here? 99.73. Please note, this 99.73 is applicable if you drive the car in an extremely careful condition. Because your car size and road size are almost same, yes or no?
Yes.
Even if you make a small mistake, what will happen? Your car will immediately get damaged. So the maintaining the 99.73 is
How you
extremely
derive
difficult.
at a 99.73%?
Yeah, I'll
What
tell
is
you.
the kind of
That's statistics. So 99.73 can easily drop to 95 or 90. All of you agree?
Yes.
Yes.
This is what all of you know. Normally you achieve a success rate of 90%, 95%, simply because most of the time you people design the process or develop the process in a way that you consume all the tolerance given by the customer. So hereafter, don't design or develop the process in such a manner. Ensure you consume even the tolerance only in the required quantity. Just because customer has given a tolerance, don't try to consume everything. Imagine your salary is 1 lakh. I'm sorry, it's a low salary nowadays, but anyway, I'm saying how much is the salary? 1 lakh. And your wife, every month she is spending 1 lakh as the expense. Are you capable now?
No.
No.
It looks capable, but then, any emergency, anything happens, you will struggle. Isn't it? Suppose if there is a delay in the salary getting credited, then there will be a struggle. So mere capable scenario is known as 3 sigma capability. Suppose you change this scenario. Your earning is 1 lakh, but your wife spends only 50,000 rupees. How is the scenario right now in your family? Easily manageable, yes or no?
Yes.
Yes.
This is called doubly capable scenario. And this is called 6 sigma capability, right? And in a 6 sigma capability, your success rate is 99.999. Please note, it is a long-term success. If you design a process or develop a process in this manner, just capable manner, the success rate appears to be 99.73, but that is not true. Because it is, if everything goes as per the plan, then only it is 99.73. Normally, thing, always, people can easily deviate the plan. So 99.73 can drop to 95 or can drop to 90, and that will be the actual, success experienced by many of the company. And so there is a compelling reason to elevate the capability of the process higher than the 3 sigma capability. And if you bring it to 6 sigma capability, imagine your success rate. Failure has become almost a rare event. So we will develop our understanding about 6 sigma slowly. So don't worry about how I am writing all these numbers. But then this is this is how nature will behave. This is a property of normal distribution. What is this? Property of normal distribution. See here, if we consider the age of our participant, you all told me the average age is 35. The maximum age is, let us say, 50. And minimum age is, let us say, 20. Am I right?
Yes.
Suppose if I have to run a digital marketing campaign, then I must target people in the age group of 20 to 50. Is my decision correct? Now, what percentage of the people will be closer to 35? Let me divide this region into 3 parts on the left side, 3 parts on the right side. 35 here, 50 here. What is this distance? 35 to 50? 15?
15.
So 5 here, 5 here, 5 here. Am I right?
Yes.
So my process average X bar is 35. My process standard deviation is 5. Can you see that? Am I right? Process
Yes.
standard deviation is 5. So if I draw lines here, 1 standard deviation plus or minus 1 standard deviation, right and left, this will cover almost 68% of my participants. Am I right? What is this point? 40. What is this point? 30. If I simply count the participants in the age group of 30 to 40, 68% of today's batch will be in the age group of 30 to 40. Looks logical?
Yes.
Very good. Now I will go up to this. What is this point? 25. What is this point? 45. Now I want to widen the age group, 25 to 45. Now what percentage of the participants are coming now? Close to 95%. Now what is the last option for me? I should take 20 and then 50. If I take 20 to 50, almost all of you will be coming under now. Yes or no? Yes or no?
Yes.
Yes.
That is why I say 99.73 here. If you go up to the 3 sigma limits, nothing but the upper control limit and the lower control limit, 99.73% of your data points will definitely fall inside the control limit. Do you understand, all of you? Please remember this rule. This is how any process will behave if it is running naturally. Just design and then leave it. Don't influence it, in between. Then what will happen? This will be the scenario. These are known as properties of normal distribution. How many of you understand the characteristics of the normal distribution? First of all, normal distribution will be a kind of bell curve. Am I right?
Yes.
Can you see an inverted bell here? Yes. And then the bell curve is symmetrical at the center. Am I right?
Yes, sir.
The bell curve is, if I draw a center line, the bell curve is symmetrical. All right. 99.73% of the points will fall inside the control limit. Do you understand this property? What percentage of the points are expected to fall inside the control limit? 99.73. Hereafter, you must remember this. This is proved. This is a proven rule. It's a property of bell curve, normal curve. And if you want to verify this, you can verify. How can you verify? You collect data. You simply collect data. Let us say, you meet 1,000 people. You meet 1,000 people,
Sir,
measure every individual's height. What is the characteristics you are measuring now?
Height.
Height. Suppose, instead of measuring your age, if I measure your height, the average height will be how much? 5.5 feet, am I right? Maximum height will be 6 feet, am I right?
Yes.
And minimum height may be 5 feet. Now I know all of you will be in this range only. The 6 is my upper control limit. The 5 is my lower control limit. Majority will be having the age around 5.5, sorry, having the height about around 5.5. Now, how many of you are having a height above 6 feet here? Can you raise your hand here? Very few, isn't it? Very few. The very few will be represented beyond the control limit. Similarly, how many will be below the 5 feet? Probably lesser, isn't it? So that is why we always say inside the control limit, you will get 99.73% of your data points. Clear, all of you? I suggest all of you to even read some literature about normal distribution,
sir,
right? Because it's
sir,
the theory has been developed after a lot of research. Yes. Come on, yes.
sir, specification limits are predefined, but the control limits are how to take in.
Control limits, I told you, no. You have to find out the point which is 3 standard deviation away from the center. What are control limits? Points which are a point which is 3 standard deviation away from the center. I will probably write down a formula for you. See here, there is a process, right? What is this? Oh God. Yeah. This is the average X bar. And here is the control limit, upper control limit. And the formula of the distance between average and control limit will be how much?
3 sigma.
So formula for control limit will be upper control limit is X bar plus 3 sigma. All right. Then lower control limit this side. Now one of you tell me, for lower control limit also the distance is 3 sigma. So what will be the formula?
X bar minus 3
Sir,
sigma.
X bar minus
minus
3 sigma.
Beautiful. Now you know the formula for upper control limit, you know the formula for lower control limit. So you know the extreme outputs from that are expected from your process. Right?
So X bar is considered from the samples batches, the average. Yes.
Yes. How do you know the average? Only after collecting samples. More the samples, better is the prediction. Better will be the understanding.
Sir, one
All
more
right.
doubt. How many samples minimum required for the average collection?
Normally sample size is vary from 2 to 25. 2 to 25. But more than the sample size, what is important is sample frequency is important. What is important?
Frequency.
Sample frequency. And another important point is sample collection period.
Yes, sir.
What are the 3 things I am telling you? First thing is sample collection period. Suppose if I want to judge your blood sugar level. I want to judge your blood sugar level. Tell me what should be my sample collection period. How many days I should collect your blood sample? Tell me.
3 times.
For every
1 week. Isn't it?
yes,
7 days is enough. So sample collection period is fixed.
1 week.
Now every day, how many sample I should collect?
3 sample.
3,
Maybe
4.
Any every day one sample. First of all, sample collection frequency is every day once I am going to collect the sample. All right. And then every day I decide, I will be sample collection frequencies once. Now, how many blood sample I should take? Normally, blood sample one is enough. You know why one is enough? Because we get accurate estimate of the sugar level. Yes or no? We have a standard, well-established procedure. So just a sample size of one is enough. But then to perfect my decision, I planned my data collection spread over a week. In a week time, how many data I will get?
7.
7. Now the average of the 7 can give me a exact measure of your blood sugar level. So what is the sample size here in our discussion? 1. Just a sample size of 1, we are able to judge your body sugar level. Suppose if somebody get your sugar level tested one more time, the reading will be more or less close to your finding. Agree?
Yes.
Yes, sir.
So more than the sample size, what is important is sample collection frequency, sample collection period. Yes or no?
Yes.
Yes, sir.
In the place of one sample, if you take 2 or 3 samples, normally for blood collection, people don't take 2, 3 samples. But in your company, you can always take multiple samples. A group of sample is known as subgroup. And number of samples inside the subgroup is known as subgroup size or sample size. If you plan in this manner, sample size anywhere between 2 to 25 will be a fantastic sample size. Clear?
Please.
But we have to deep dive all the subject, is a separate subject by its nature. You have to spend enough time. All right. So now you understand, all of you, to improve the process performance, you need to decrease the variation. That's all. See here, if I decrease the variation, my entire process operate comfortably inside the spec. This is the Six Sigma approach. So what is Six Sigma? Six Sigma is a metric. It tells you how much capable your process is. It tells you what is the success rate you can expect. It tells you what is the failure rate you can expect. Six Sigma is actually a methodology. What is the methodology Six Sigma gives? It's a problem solving methodology. The methodology is DMAIC, define, measure, analyze, improve, and control. And Six Sigma is a way of management. Your company can believe in the expertise of the people, not just their age, not just their educational qualification, or not just their experience. Rather, believe your people based on the skill set. That is called using Six Sigma as a way of management. There are companies who believe in Six Sigma way of managing their people. Caterpillar, Amazon, and for example, the original company Motorola. Motorola established a separate university to train their employees. Similarly, Caterpillar, they have their own university. They certify their employees on their own. Amazon, they certify their employee on their own. That those certified employees are always, given, preference in everything. Better package, better compensation, better incentive, better promotions. They grow very fast in their career. So Six Sigma can be a way of management. You can differentiate people based on the belt level, not on the age or not on the experience. If you really wanted to grow fast, don't wait to become a senior citizen. Just upgrade your belt level. You will grow very fast, right? That is the message here. And then Six Sigma is a philosophy. Whatever we discussed, all are applicable in our day-to-day life. All of you believe in this? Six Sigma is a philosophy. Many people, even 90% of the professional, they think that Six Sigma is applicable only in manufacturing industry. I am telling you, you can gain an effective control over your body parameters. You can gain an effective control over your health parameters using the Six Sigma methodology, the principles and the tools and techniques. It is a philosophy, can be applied wherever you want to apply. All right. So it's a metric, it's a methodology, it's a way of management, and it is a philosophy. And methodology is broadly classified into 2 types. One, methodology for improvement. another methodology for development. See, problem can be solved proactively, problem can be solved reactively. You understand the difference?
Yes.
Even before the problem can happen, if you want to prevent it, then you are proactive.
Yes.
After there is a complaint and then you act on it, then you are reactive. The reactive way of problem solving are known as improvement. Proactive way of solving problems is known as development. All of you, do you understand the difference between improvement and development?
Yes.
For improvement, the methodology is DMAIC. For development, for example, you want to develop a new product. The methodology is DMADV. DMAC stands for define, measure, analyze, improve, and control. DMADV stands for define, measure, analyze. First three are same. The fourth one is design. The fifth one is verify. And then you have to repeat the cycle till you come to the satisfactory level. All right. So one method for improvement, the other method for development. Now let's take a deeper look on the DMAC methodology. What is define? Define means a problem well defined is half done. There is a famous proverb, right? Well defined is half done. So first thing is, you have to thoroughly understand the problem. You remember our discussion, one of the 7 important skill is listening. Am I right?
Yes.
If you are a poor listener, all your suggestions are going to be waste because you have not listened to the problem, isn't it? So in Six Sigma methodology, the first phase is define. Put all necessary efforts to thoroughly understand the problem. The problem is considered to be understood, considered to be defined if the entire problem is made measurable using a single metric. I repeat the statement. A problem is considered to be defined if the entire problem is measured using a single metric. That metric is known as CTQ metric. That metric is known as CTB, critical to quality or critical to business metric. All of you, do you understand? You say that, sir, I have a health issue. But what is health issue? What exactly is the health issue? Sir, my cholesterol level is high. Now the problem is defined. Yes or no? Can a doctor give you a treatment if you say, sir, I have a health issue?
No.
No. You have to drill it down. What is exactly the problem? Which organ of your body is experiencing the problem? What is the metric that can indicate the intensity of the problem? Your cholesterol level can indicate. Your sugar level can indicate. So everything is a separate problem, isn't it? You can't treat all problem together. Can you think about what to say? One medicine for 2 kinds of health issues? No, isn't it? So you try to specifically define the problem, express the problem using a single metric when you are considered to have defined the problem. Once the problem is well defined, move on to the measure phase. What cannot be measured cannot be improved. All of you agree? If you cannot measure something, you cannot improve that metric. So in measure phase, our objective is to measure the intensity of the problem. What is our objective? Measure the intensity of the problem. When you are measuring, you must measure without error. If you want to get your blood tested, you should go to a proper NABL accredited laboratory, isn't it?
Yes.
You can't go to a bunk shop on the roadside and then get your sugar tested. That may not be helpful, isn't it? Your data must be free from error. All right. So measurement error, normal practices should be less than 10%. It's an industry practice. And we'll talk in detail about measurement error later on. However, measurement error should always be less than 10%. And what is this 10%? I will explain later on as we deep dive. If you don't understand the concept of measurement error, you are simply deciding to drive your car, keeping your eyes closed. I don't know where will you reach. You might be taking decision using data, however, still it can be wrong. So you should definitely be concerned about the error that is getting accumulated in your data. You should find ways to measure the measurement error and ensure your data is clean, credible, and worthy enough for analysis and any calculation. All of you agree with me on this?
Agreed.
Then only data must be collected. Otherwise, even after collecting the data, you may take a misleading decision. To avoid that, data must be error-free, and then you use the data to calculate the intensity of the problem. Intensity is nothing but the baseline performance. Where are you right now? What is the target? What is the gap between your current position and the target? That is known as the gap in performance. Once the gap in performance is measured accurately, move on to the analysis phase. In the analysis phase, I have already explained, you have to conduct a root cause analysis. What are you supposed to do? Identify the root cause, validate the root cause, study the relationship of the root cause, study the sufficiency of the root cause. I think I don't have to explain it again, isn't it? You finish all these activities, then you are fit enough to move on to the next stage, improve. In the improve phase, our concern is about the solution. You will be able to talk about the solution if you go through these three phases properly.
Hey,
Any mistake made here will lead to developing a poor solution. Isn't it? Any mistake you go through here will lead to developing a poor solution, right? If you are really concerned about the right solution for the problem, go through all the phases properly. Don't compromise. All right. So solution generation happens at the improve phase. Once the solution is generated, you gain the consensus of the team member and your boss, and then implement the solution. All right. All that part of your improve phase. Now control. Control is finding ways and means to sustain the solution. Finding ways and means to sustain the solution. That means your daily habits must necessarily change now. Yes or no? If your cholesterol levels have gone high, somehow you have reduced it. Now you must necessarily focus on changing your daily habits. Yes or no? Otherwise, again, your sugar level will go high. That is called, the control phase. Control phase, the main output is a control plan, a procedure to be followed, as your daily habits. So in define phase, your focus is on the problem. Problem is on the y variable. In the measure phase, you are measuring y. In the measure phase, you are measuring y. In the analyze phase, you are thinking about the root causes, which are nothing but the X factor, the critical X. So no, see your focus is now shifting to the right side. And then in the improve phase, you are correcting the X. What are you doing? You are correcting. The range of operation of the X factor is now corrected, because when I correct the range of operation of my X, automatically my range of operation for the Y will get corrected, isn't it? All right. And then in the control phase, I will be controlling my X, because I know certain factors are the culprits. So I will monitor them, control them on a daily basis, so that the same problem cannot come again. All of you, do you find this method really powerful enough to solve any problem? Define, measure, analyze, improve, control. You are not leaving any useful piece of information here. You are closing all the doors through which the root cause can escape. You're not allowing the root cause to escape from any of the doors. That's why I always say this is a very supreme methodology for problem solving. All right, so how are you going to master this? You are going to master this by learning all these phases step by step. Every phase of the Six Sigma methodology is divided into 3 simple steps. Define phase, 3 steps. Measure phase, 3 steps. Same manner, analyze 3 steps, improve 3 steps, control 3 steps. Totally how many steps? 15 simple steps. Hereafter, all my sessions will be teaching you step by step. What is first step? What are you supposed to do? What is the deliverable expected? What kind of tools and techniques you need to use? That's how we are going to move further so that you become an expert in all the 15 steps. If you become an expert in all the 15 steps, then you can lead a complete project and you can guide others also, right? I'm not going to read out all these steps right now because that will be the entire course. I will be explaining it, in the upcoming session. So here
Previous,
you want to see the
previous
slide,
slide.
right? Yeah, this one.
No, sir.
You want the previous one also?
Yes.
Okay, you can take a screenshot if you want. But then all these slides are there in the course material itself.
Yes, sir.
So there are 15 simple steps using which you can eliminate any kind of defects and any kind of waste from any business process. All right. And now here is a mapping of various tools and techniques phase wise. But then it is not a complete list. It is just my recommendation based on my experience, right? In most of the projects, these tools are used widely in define phase, measure phase, analyze phase, improve phase, and control phase. And again, I'm not going to read out, I'm not going to explain anything. Rather, we will be learning the tools one by one because you can't learn all the tools together. You have to spend quality time to master each and every tool. That will happen as we progress. So some of you, that's why, if some of you, if you really wanted to upgrade your belt level, now is the right time because you are in a right platform with the company of the right mentor, and then you have the right opportunity coming in your way, right? And please upgrade. Otherwise, what happened? All the basics are needed to upgrade, to a greater level. Without the basics, one cannot really, master all the tools. So now that we have built enough basics, so if you really wanted to move up in the ladder of Six Sigma, yes, you can do that. And so reach to the same coordinator who onboarded you so that you can upgrade your belt level also. All right. And now as a small check before we close the session for today. Tell me, what is the focus of Six Sigma? You need to answer my question now. Is the focus is reducing defects or reducing waste?
Reduce defects.
Reducing defects.
Reduce
Good.
defects.
Perfect understanding. And Six Sigma originated from which company?
Motorola.
Motorola.
Motorola. Very good. Very good. Very good. Who is known as father of Six Sigma?
Option.
Option, you want options, right?
It's a
Will Smith.
Will Smith.
Will Smith. Will Smith. He is an engineer in Motorola.
Yeah.
And what is the focus of Lean?
Reduce waste.
Reduce waste.
Reducing waste. So what is a waste? Non-value adding activity.
Non-value timber.
It's a form of inefficiency.
Timber.
It is excessive consumption of resources. You should know all this, right? And an organization want to improve their existing product. Which Six Sigma methodology should they use?
PMAC.
DMAT, because it is an improvement.
Yeah.
DMAT V is otherwise called as, I did not teach you.
A development tool.
Very good. It's a development tool, but it is given a specific name known as Design for Six Sigma. In shortly, it is known as DFSS. Very good. What do you mean by effectiveness?
Effectiveness is generally reducing defect.
Very good. Is the ability to produce defect-free products. Is the ability to offer defect-free services. In general, ability of a process to produce defect-free outputs or error-free outputs. That means you have to do things right at the first time. Am I right? That means the expectation is you must do the things right at the first time. Doing things right at the first time is Six Sigma. No rework allowed. Doing right things right at the first time. Now, what do you mean by efficiency? Efficiency means
to reduce
Reducing
the
waste.
waste. Reduce
reduce
the
the
waste.
waste. I accept. That means consuming exactly required resources. Consuming exactly
Sir, your
required.
voice is not clear.
Oh, my voice is not clear. Is it okay now?
Yeah.
Should be
Yeah, it's
okay.
okay.
Okay. Some internet, no issue. So consuming exactly required resources And efficiency means waste-free operations. Efficiency means staying productive throughout, the operating time, which means you should not only do the right things, do the right things in a right manner. You should not only produce quality products, you must produce quality products efficiently. All right. So the one is Six Sigma, the other one is Lean. Please note, you must focus on both. While focusing on efficiency, don't lose effectiveness. While focusing on effectiveness, don't lose efficiency, right? One must complement the other. And now, what do you mean by root cause analysis? What are the stages?
Identification.
Identification, validation,
Study the correlation.
sufficiency of the
Study the relationship.
Sufficiency of the
Very
root
good, beautiful. Please note, in order to identify the root cause, fishbone diagram can help you. But in order to validate the root cause, some experimental data is required. Only with the data you can validate. And once validation is done, again use data to study the relationship. And then finally check whether you have identified all root causes. That is known as sufficiency. That's it from me. Now the basics, you have a strong basics to master DMAC methodology, to master the tools and techniques of Lean and Six Sigma. Thereby, once you master those tools, you can be declared the yellow belt or the green belt or the black belt, right? Depending on the level of competency you acquire. So I wish you the best learning journey further with the program. And now the foundation is laid strongly. So any questions? Anything?
Can you please show the last slide?
Last slide is thank you.
Before that.
You want to see the slide previous to it?
Yeah, one slide before.
Yeah, yes.
Sir, is this available in that study material site, whatever the link has been provided?
Yes. It is available.
When it will be provided?
Everything is there.
No, it is available. It is provided. It is mailed to you. But then only people who have completed the formalities will receive it. Formalities in the sense you must submit application and certain things. But however, the material will be shared Monday one more time. So all of you will get it. Don't worry. But please make sure you also cooperate with the procedure because it's a Government of India certification program. Without receiving your application and documents, we will not be able to issue the certificate. So please
we
do
won't.
follow. Yes, madam.
So we won't be getting that e-certificate like after
You,
the exam.
you will be getting the e-certificate. You will be
So
getting. You
what is
just
the
have to follow our
procedure?
guidelines.
Okay.
See, the message, there are coordinators, right? Some of you will be coordinating with Akash and some of you will be coordinating with Prabhakar, right? So please just, provide them the needed information. That's all. Then you will be fully comfortable. Otherwise, you might see some gaps here and there, like watching the recordings or, receiving the course material, receiving the certificate. Everything requires your cooperation also. And all the payment details you have to share. So please ensure you don't leave anything unfulfilled. Check and then check whether you submitted everything. And then our team will definitely come forward and then sort out all issues for you. But we wanted to ensure all of you, have a very comfortable learning with us. But then little cooperation expected from your side. Got it?
Sir,
Yes.
sir, is there something called as 4 Sigma?
Yes. If Six Sigma, I have explained you Six Sigma, I have explained you Three Sigma also, isn't it?
Yes, sir.
The distance between the process center and the nearest spec. If that is equal to Three Sigma, the process is Three Sigma process.
Yes, sir. So can you give me a little bit of explanation on 4 Sigma?
See, imagine you have a parking area.
Okay.
You have a parking area and you have a car. If your car is exactly equal to the size of the parking area. Now, what is your process right now? What is the capability of your parking process?
It is
3 sigma
exactly.
capability.
Yes.
Am I right?
Yes, sir.
Your car size is equal to the parking area. Suppose after parking your car, still some more space is available, additional space is available. That means it is a process better than 3 sigma, yes or no?
Yes.
Depending on the gap available, it can be classified as a 4 sigma or it can be classified as a 5 sigma or 4.5 sigma, all that. But suppose if you come to a scenario where the size of the car is half the size of the parking area, now your process becomes 6 sigma process. This much is enough in the first class, right? And slowly you will get to understand everything. Then you will define what is 4.5 sigma, what is 5.7 sigma, everything you can explain, even 7 sigma or 8 sigma. The narrower the process, more capabilities.
On
Narrower the
what
process.
basis do we, so on what basis do we set these sigmas?
See, I told you, no, you must collect data. Without data, you can't comment about any process. If you ask me to come to your company and then, give you some piece of advice, first thing I need to look at is your process data. Yes or no?
Yes, sir.
Otherwise, I cannot talk. I must collect data from the process. Let's say I have 100 data. Now, the first thing I will be doing is I will be calculating average. You know why I will be calculating average? I will check whether your average is close to the target or not. Yes or no?
Yes, sir.
And then I will be calculating the control limit. I have a formula, average plus 3 times standard deviation. In order to calculate control limit, I will be calculating standard deviation first. I will be calculating standard deviation first. And then average plus 3 times standard deviation is my upper control limit. Average minus 3 times standard deviation will be your lower control limit. Now I can understand the spread of your process.
Okay.
Do you understand?
Yes,
To
sir.
what extreme your process can go on the right side? To what extreme your process can go on the left side? And then I will check whether the extreme cases are inside the spec or outside the spec. If the extreme cases are inside the spec, that means everything is inside the spec. Am I right?
Yes, sir.
Suppose if the maximum mark scored by the participants here is 90 and the minimum mark scored by the participant here is 80. Now everyone is above the pass mark because the pass mark is 60, isn't it? So if the extreme cases are acceptable, everything is acceptable. Clear?
Yes, sir.
That is why we say, that is why we declare a process as a capable process if the control limits are seen inside the spec. All right. See, you must have a complete clarity on customer target, upper specification limit, and lower specification limit, without which defining Six Sigma will be a tedious job. And then you must understand any process will exhibit a bell curve. You must start believing in that. Read some literature if needed, right? Try to understand normal distribution. Or if you really wanted to conduct an experiment, please collect any data which is possible. Only requirement is it should be accurately measured data. That's all. Collect accurate accurate data and then tabulate in an Excel and plot some graph. You will be surprised to see a kind of bell curve getting formed, right? And that will happen. And then all the concepts can be applied. And plus average plus or minus 1 sigma 68%. Average plus or minus 2 sigma 95%. Average plus or minus 3 sigma 99.73%. Remember this rule. These are known as rule of probability. So don't worry, you will get to understand the meaning of Six Sigma further deeper as we develop additional knowledge in the course. Okay. Any other direct questions? All good?
Yes, sir.
Yeah.
Yes, sir.
Okay then. Okay. Then thank you very much, all of you, for your fantastic participation on both day number 1 as well as day number 2. And I look forward for the future sessions with all of you. Next Saturday again, Saturday, Sunday, again, we'll be going through similar sessions. You will also meet some other trainers from our platform. All of them are, senior level and experienced people, and you will definitely love the way all the trainers, delivering the session. I hope your experience with me was, good both yesterday as well as today, right? So wish you all the very best, and we will be meeting again next week, next Saturday. Thank you very much. Good night.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.